Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
You and me repeat. bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet bittersweet heat is suffocating.
Hi, everyone.
Hello.
Hey there.
Oh, I think we can't hear you, Anuradha.
Well, let's just then welcome everyone to TestJS Summit 2022. Welcome. Thank you for being part of this event here with us. I hope you can all enjoy the talks, and also don't forget to ask questions afterwards on Discord. Our speakers will be extremely happy to answer. Cecilia, would you like to take it away?
Yes, absolutely. Thank you so much, Valmer. Thank you everyone for being here today. My name is Cecilia. Let's go ahead and we'll get the slides going here as well. Yes, perfect. So my name is Cecilia Martinez. I am a developer advocate at Ionic. I am also really excited to be emceeing today with TestJS Summit. And a little bit more about me. I am part of the GitHub Stars program. I am a volunteer with Women Who Code Front End. And I also am the chapter head for Out in Tech Atlanta, which supports the LGBTQI+ community in tech. Very passionate about testing. I previously have been at Cypress and also Replay, a debugging platform. I love working with open source developer tools and building inclusive developer communities. So Valmir, do you want to take it away to introduce yourself?
Can you hear me, Piotr, now?
Now we can hear you. Yeah. Thanks, Cecilia. Pretty excited to be here as well. My name is Valmir. I'm a software craftsman who loves testing. I'm also a senior quality assistance software engineer at Typeform. I'm also a blogger, YouTuber, podcaster. I'm a Cypress.io ambassador, online instructor on both Udemy and Coursify. I'm an active member of the testing automation and JavaScript communities, and personally, I'm a big fan of music, tattoos, vegan food, and skateboarding. If you want to know more about me, you can visit my website. It's valmir.dev, WALMYR.dev. Anuradha, I hope everything is working fine on your side, and take it away.
Thank you, Valmira. Sorry for the hiccup, but hey everyone, I am Anuradha, working as a front-end consultant at Passionate People Amsterdam. I'm a Google Developers Expert for Web, Microsoft MVP, Cloudinary MD, and Women Techmakers Ambassador. I'm also an accessibility advocate, and I really love talking about accessibility and sharing information about it around the conferences around the world. So yeah, let's get started. Back to you, Cecilia.
Thank you so much. So wow, what a number. We have almost 5,000 people registered this year. So thank you so much for all of these wonderful attendees for being here. It's been really exciting to have you join us to talk about all things JavaScript testing. Anuradha?
Wow, 5,000 is a lot of number. And what is even more exciting is that all of you people are from all around the world. So just look at these dots, which are like from where you all are joining around the world. It's so nice. Thank you for all for being here, and like good morning, good afternoon, good evening to you all, because I think the time will be different for you all. So also, we will be having some activities throughout the day where we will be asking some questions to you. Our speakers have some questions for you, and we will be using Slido where you can go and answer those questions. So go to sli.do or scan the QR code on the screen and then enter the code 0304. Take part in the poll, and we will discuss all the results after each talk. But for now, let's see how it works. So we have a question for you right now. So if you go to Slido, 0304 is the code, and please answer it for us. What is your favorite JavaScript test framework? You can choose testing library, Jest, Vitess, Playwright, Cypress, Storybook, Puppeteer, Mocha, Jasmine, and so on. Just go ahead and let us know what's your favorite one. And we will discuss the results in a while. Also, thank you so much to the program committee who has created such a wonderful lineup for the conference. So thank you to Alex, Cecilia, Valmir, and Stefania. So yeah, Cecilia and Valmir, you are here with us. Thank you.
Thank you so much. Yes, and a huge shout out to our sponsors who support TestJS Summit. We have Sauce Labs, Stackhawk, Stream, and Yoast here today supporting us. Thank you so much for that support and making this all possible. Valmir?
Sure. Also, would like to thank our media partners, CodeStack, YouTube channel about web development coding languages such as HTML, CSS, Sass, JavaScript, and TypeScript. Thank you for your support, and back to you, Cecilia.
All right, great. So we want to see Twitter full of today's event. We want to see, how you're watching, get a sense of what talks that you're watching. So you can tweet at us with the hashtag TestJS Summit. We'll be keeping an eye out for your tweets on Twitter, and we'll have a raffle of multi-passes to Get Nation Conference and some really cool t-shirts. So make sure that you use the hashtag TestJS Summit to tweet at us today as you watch and participate in today's event. So here's an example of some of our tweets that we fired off this morning. We're super excited to get ready to MC for you today. And as you can see, we are using that hashtag TestJS Summit. So if you tweet with hashtag TestJS Summit, you'll get to win some really cool prizes, such as some neat t-shirts that we have here, just like this one on the screen. And the other prize is for 3 winners, we'll get a Get Nation multi-pass. This is a really great prize because the multi-pass gives you remote access to many different types of JS conferences like Remix Conf, React Day Berlin, JS Nation, TechLead.js, and many more. You can find out more about the multi-pass on the Get Nation portal at portal.getnation.org/multipass. And for all the agenda information that you need for today's web event, you can visit testjssummit.com. Anuradha, back to you.
Thank you. So if you go on the website, here is how the navigation on the website will look like. So the main screen will have the video player that plays the live feed. So maybe you are watching us from there right now. And the main screen, and on the bottom, you got a timeline of events that are happening in the summit. Below the player, you can see a track of the talks. Here you can see what is live at the moment and what is coming next. Then there is a track with speaker rooms. Just click on them and you will enter Discord, where in a separate space, you can talk to the speakers directly. That sounds so cool, right? And also you can join the discussion rooms in Discord as well. And we will talk about discussion rooms just in a while. But before that, if you are lost at any point in time, write to us in troubleshooting channel on Discord. We are there to help you and make your conference experience awesome.
All right, so we're also going to be using spatial chat if you want to hang out with the remote audience. If you want to join any discussion or speaker room, you can click on the room in the menu, and you can also watch talks together with fellow attendees and discuss them right away as if you were in the room together live. Be sure to also join the Discord server. You'll use the TestJS Summit channel to submit questions for the speakers. We have 2 different track channels. So to join, there is a link on the watch page, or there's also a link that was sent out in the emails. Let's go ahead and test it now. So go to Discord and make some noise on either the Q&A production track or the Q&A local host track channels. Post your favorite emojis, GIFs, say hi to everyone. I think we've already seen some GIFs pop up in the channel so far. Everyone's getting really excited for all the great talks we have today. So again, you can check out community, the Q&A production track, which is the track you're watching now, Q&A local host track, where we have even more great talks lined up for you. So go in there and make some noise. We will also have a great after party program that everyone is welcome to participate in. We'll be playing a fun game of draw battle, and we'll have lots of fun in the chat, getting to know each other and discussing the day's program. So as always, on a serious note, we want everyone to feel safe and have a good time during the event. We do have a code of conduct at getnation.org/COC. Please make sure that you read it now, and if at any time you feel there's been a violation, email us at coc@getnation.org, and we will take care of it right away. We do not tolerate any form of harassment in any of our channels, including the Discord, Spatial, or anywhere else that you will be interacting with the conference. Wilmer?
Thanks, Cecilia. Also, don't forget to take part in the discussions around testing. These discussions are the ones scheduled for today. So one of them will be about testing complex architectures, which will happen at 17:10 Central European Time, and at 18:30 also Central European Time, we'll have a discussion about the future of testing. So feel free to join the debates via spatial.chat or from the timeline under the player. And there will be more discussion rooms tomorrow, so don't miss them too. If you are looking for a new opportunity, you can check out the job offers from our sponsors at testjssummit.com/jobs. And also, we want to invite you to take a look at the special offers from our sponsors at testjssummit.com/perks. Finally, your feedback is very important to us. It helps us keep making this event better every year. We have a form available to you at testjssummit.com/feedback. So please take some time to leave your feedback there and your thoughts. The form will be available throughout the whole event. And that's it from my part. Cecilia, back to you.
Thank you so much, Valmer. So before we kick things off, hopefully you've all been voting for your favorite testing framework in Slido. We're gonna go ahead and take a look at those results now. All right, so looks like Cypress is the winner at 54%. Also, Just, Playwright, Testing Library, Storybook. Looks like we're getting some last-minute votes in here for Mocha as well. But you can check out the full breakdown of those results at slido.com or sli.do. Thank you so much for participating. We will definitely be hearing a lot about many of these different frameworks today. So we'll go ahead and get started. Let's get a huge round of virtual applause for our very first speaker on the production track. We have Marie Drake at Grafana Labs UK with a talk about a medley of front-end and back-end performance testing. I'm a big fan of Marie. I have known her for a while. We've interacted a lot with my work at Cypress, and I'm a big fan of her accessibility and testing resources and content. She is a developer advocate at K6.io, which is a Grafana Labs company. She's also a tech blogger at testingwithmarie.com, an accessibility advocate, and an online course instructor at Ministry of Testing and Test Automation University. We'll actually start things off with a poll question from Marie. So you can go to sli.do, code 0304, to answer this question. It's a little bit of a quiz, actually. So K6 is primarily known as a load testing tool. However, it can also be used for the following except, and the options here are chaos experiments, browser testing, contract testing, and unit testing. So again, Which of the following can K6 be used for except? And select your answer there. We'll take a look after Marie's talk what the results are. Make sure that you ask your questions on Discord in the Q&A production track channel, and we will have Marie join us for a Q&A after her talk. Let's go ahead and give her a big round of virtual applause now. And Marie, the stage is yours.
Hey everyone, my name is Marie and welcome to my talk called A Medley of Front-End and Back-End Performance Testing. Before I start with my talk, I want to tell you a story first. This story is about Overcooked. I've been playing this game with my 5-year-old daughter, and if you're not too familiar with Overcooked, it's a cooperative game where you have to pause different unusual kitchen layouts and serve as much food as possible to customers. When the game starts, it's still pretty normal. Orders are flowing in nicely, and you're getting tips because you're getting sushi orders served on time. As the game gets harder and you get more orders than expected, the kitchen is now overwhelmed, and without proper coordination and teamwork in place, the kitchen is now on fire. You're also not getting tips anymore, and you've got hungry customers waiting impatiently for their food. Because the kitchen can't keep up with the overflowing orders from customer, the whole kitchen is now on fire. Of course, this is very dramatic, but ultimately, you get the picture. The customers are very unhappy, you're getting negative tips, and the kitchen is such a mess that you can't even cook a single potato. Going back to my topic of performance testing, imagine you are trying to buy some items during Black Friday or Cyber Monday sales. You found an item that you really like, but suddenly the website that you were using has crashed. It can't keep up with the overwhelming requests from different users simultaneously. This is a very common phenomenon during Black Friday sales. You can see in this example graph as well that during the peak times of Black Friday sales, the response times are significantly higher as opposed to normal periods. This has then resulted to response times errors that can break your website. Most of the time, the response from companies is to buy more servers, thinking that this will fix their performance problems, but this could end up costing you more money. A better investment is if you understand, test, monitor, and make performance improvements to your internal application. Now, let's get to the more serious part of this talk. In order for us to make sure that our users have a positive user experience, we need to do performance testing. Performance testing is the practice of measuring and evaluating how your system responds under certain conditions. When you think of performance testing, we are concerned about the speed, reliability, and stability of the application that we are testing. With performance testing, there is often a misconception that it's all about load testing. Performance testing is the umbrella term for any type of performance test, while load testing is just one type of performance testing. In a nutshell, load testing checks how your application is behaving if it's been exposed to a heavy number of concurrent virtual users sending multiple requests at a given time. Within load testing, there's also different variations such as stress testing, soak testing, or spike testing. Performance testing is typically divided into two areas. We have the front end or client side performance, which is aimed at testing how fast a user can see the web responses instantly. It is concerned with the end user experience of an application, which usually involves a browser. Front-end performance testing has metrics that are distinct from back-end performance testing. Example metrics could be how long did it take for the browser to render the entire page, or how long did it take for the page to be fully interactive. Then, on the other hand, we have back-end or server-side performance testing, which is aimed at ensuring that when multiple requests are sent from different users simultaneously, your backend should be able to handle the load accordingly. Example metrics could be how long did it take for a response to come back from a specific request, or how many failed requests did we encounter? So as you can see, performance testing is not just about load testing. With different types of performance testing, you might wonder if there is a priority as to which one is more important. The answer, as with everything, is that it depends. It always is. If we revisit the golden rule of web performance, it states that 80 to 90% of the load time of a web page or application is spent in the front end, while 10 to 20% is spent in the back end. You can see in this image, which I took from Steve Souders' blog, that the average front-end time is significantly higher as opposed to the back-end timings. If we are following this golden rule and you want to make some performance improvements, it's always a great idea to start on the front end and make small recommendations to your team. Performance testing on the front end is also much closer to our users' experience. However, the golden rule of web performance is not always necessarily accurate. If you have a lot of traffic arriving at your website, the front-end response time can remain roughly similar. But once your backend struggles with the increased concurrency, the backend time will grow exponentially. Front-end performance testing is executed on the client side and is therefore limited in scope. They don't provide enough information about your entire application. Backend performance testing is really useful when it comes to catching any performance bottlenecks when your application servers have been exposed to high levels of load. At the same time, front-end performance testing can catch issues related to browsers only, which can be skipped entirely from the protocol level. This is why a mixture of both is key. Moving on, I want to talk a bit about performance testing tools because there's a variety of tools out there that are available to support you with your performance testing needs. From a front-end perspective, tools such as Lighthouse, Google PageSpeed, SiteSpeed.io, Web Page Tests, and even your developer tools can help. Other testing tools such as Playwright and Cypress can also offer ways to measure front-end performance. Then, if we go to the back-end tools, there's also JMeter, K6, Gatling, Torus, Locus, and also Artillery, just to name a few. These tools predominantly perform performance testing, most commonly load testing on a protocol level. So as you can see, you would need a combination of different tools to test your front end and back end. But what if there is a single tool that you can use for both? What if there is a tool that can simulate a browser-based test with a protocol level test so you can understand how the front end behaves during various performance events? This is where XK6 Browser comes in. XK6 Browser is an extension to K6 which brings browser automation and end-to-end web testing to K6 while supporting core K6 features. It adds browser-level scripting APIs to interact with real browsers and collect front-end metrics as part of your K6 tests. With XK6 Browser, this gives you the ability to measure how your front-end is behaving during certain event, which would be difficult to catch from the protocol level. XK6 Browser, similarly with K6, is actually written in Go, but the tests are written in JavaScript. It's also great news for Playwright users because XK6 Browser aims to provide rough compatibility with the Playwright API. XK6 Browser is still in its very early stages, so it's been created as a K6 extension, which means that it's not included as part of K6 Core yet. To get started with XK6 Browser, you need to install XK6 first via Go. Then, you have to build a custom version of K6 with XK6 Browser binary added to it. Since K6 tests are written in JavaScript, there will be some familiarity already. To demo a really simple test, I just want to visit a test URL. To create that, first I need to import Chromium from XK6 Browser. At the moment, XK6 Browser only supports Chromium-based browsers, but we also have plans to support Firefox and WebKit. Next, I have my export default function, which is our virtual user code. Anything that's inside the default function will be executed by a virtual user again and again, depending on your configuration. For now, this will only be executed once. I'm telling Chromium to launch a browser, and since I want to see the browser, I'm passing in headless as false. Then, we're telling browser to create a new page. To visit our test URL, I'm using the page.goTo method, passing in my test URL, and then wait until the network is idle. Finally, I'm just closing both my page and my browser. To run a test in XK6 browser, we just need to use XK6 browser followed by the command run and then the file name. Let's see that in action by typing XK6 browser run followed by the file that I want to run. In this example, I've saved it on a folder called examples. You can see that it has opened up my Chrome browser and it has visited the page. When that's finished, K6 prints out a summary of a bunch of performance testing metrics. Apart from the usual HTTP specific metrics that K6 already tracks, there are a few browser performance metrics that are now also added, such as browser DOM loaded, first contentful paint, first meaningful paint, and so on. For each of these metrics, you get an overview as to what the average time is, the max response time, or even the 99th percentile, among others. This gives you an insight into how performant your website is from a browser perspective. Let's make the script a bit more complex by automating a login functionality. Let's say that I want to automate typing in my login name and password and then checking that I have logged in successfully. Let's launch an instance of Chromium and notice that apart from the headless option, I'm also passing in an option called slow-mo, which slows down input actions and navigation by the specified time. Next, I'm creating a new page. I'm visiting the same test URL again and waiting until the network is idle. After that, I'm using page.locator, which can also be interchanged to page.$sign to interact with the given selectors and perform additional actions to type the username and password. Now, for some context, a lot of the operations in K6 are synchronous. However, playwright operations are async, so we're also trying to support async operations. Since clicking the submit button will load up a different page, I also need to wait for that page and use page.waitForNavigation because the page won't be ready until the navigation completes. Once all the promises have been resolved, we can check that it has loaded the new page by asserting that the text content is equivalent to what we expect. Then finally, I'm closing the page and the browser. To see that in action, let's run our tests. Similar to the previous execution, performance metrics are also reported, but there is also a check here indicating that the assertion passed. Now, the real power of XK6 browser shines when it's combined with the existing features of K6. XK6 browser allows for mixing browser level and protocol level APIs. You can have a scenario where you want to simulate the bulk of your traffic with protocol level scenarios, and at the same time, you can have one or two virtual users accessing your website on a browser level to collect front-end metrics such as DOM content loaded or first contentful paint. To see that in code, first I need to import the relevant modules from K6 as well as XK6 browser. Next, I'm configuring the behavior of my test using options, which is built in with K6 already. Here, I can run two scenarios concurrently. My first scenario is for my browser test, while my second scenario is for my protocol test. I'm using the constant vuse executor for both scenarios, which will introduce a constant number of virtual users to execute as many iterations as possible for a specified amount of time. In this example, I've set 1 VU for my browser test while I have 20 VUs for my protocol test. Next, I have my messages function, which is my browser test, and I also have my news function, which refers to my protocol test. It's all in one script, and this allows for greater collaboration amongst teams because if you have backend teams already using K6, front-end teams can collaborate more with them and be more effective when doing performance testing. Here is a sample output from the test run, and you can see both scenarios are executed concurrently with various performance metrics reported. Now, since I started my talk talking about Overcook, I would also like to end this with Overcook. Now, if we want to have better kitchen coordination, handle high amounts of customer orders, make sure that we don't have customers waiting impatiently for their food, and also provide the best customer experience, you need to have the right blend of front end and back end performance testing. Just some final words before I finish. Since XK6 browser is still a fairly new tool, we need help from the community, so you're most welcome to try it out and give us feedback. Do check out our GitHub project, have a look at our examples, and play around with the tool. That's it for my talk at TestJS Summit. I hope you learned something new today, and thank you so much for listening.
Thank you so much to Marie for that amazing talk. Super interesting. Marie, why don't you go ahead and join me on stage?
Hello.
Hey there.
Everyone. really,
Thanks
really happy to be here.
Awesome. Thank you so much for being here to discuss your talk and do some Q&A with our audience. I want to go ahead and start, though, by discussing the answer to your poll question. So, beforehand, we had you ask a question around what K6 is primarily known for load testing, but can do a lot of other things. And the correct answer is unit testing. So unit testing is the only item that you cannot do.
Yeah, that's right. And it's like really interesting here to see the results, because even though a lot of people voted for you for the right answer, there's still a few people who maybe aren't as aware that K6 can also do browser testing, that K6 can also do chaos experiments, and even contract testing in the form of a schema validation. So the main type of testing that it can't really do, because K6 is more of like a black box type of tool, whereas it's not really suited for like unit testing, because you'd really want to go deep into like the different functions. So you would want it to be part of your like actual code. You can do it, but we don't really recommend that you use K6 for that, because obviously there's like better toolings that are much available for that sort of type of tests.
Yeah, it sounds really helpful, though, to be able to have such a versatile tool in K6 and being able to cover all those different use cases without having to stand up separate tools for each of those use cases. So yeah, really, really interesting stuff. And so I also wanted to ask you back to our first poll question that we had for the audience about what is your favorite testing framework. And, no pressure, but I'm curious what your answer is there.
Yeah, I'm not gonna lie. It's, my favorite framework is really Cypress. So before joining K6, I was a Cypress ambassador, and it was the first framework that I've used. So after I was on my maternity leave, and it was just really great in a sense that it was easy for me to get started, easy for me to install, and the visual test runner was really helpful if I need to debug the test. So I think for me that developer experience, was really is a really great thing that Cypress can offer. So yeah, I'm a big Cypress fan.
Yeah, and so yeah, I mean, I can't hide it either. Obviously, a really big Cypress fan, and talking about the different use cases and the developer experience, right? Being able to leverage these tools for so many different types of things. Cypress, and K6 are similar in that space. Mm-hmm. So we are having some questions come in from the audience, so we'll make sure that we answer those for you. First one is actually about how is browser level performance testing different from protocol level?
Yeah, so I think if I go back to one of the slides that I have, so I've differentiated performance testing as either front end or back end performance testing. So when we're talking about browser level, it's really about testing the front end, that we're trying to verify if, for example, our website is fast enough from the point of view of a single user. It also has distinct metrics. So it's all about like the browser performance metrics. So an example metric could be how long did it take for the browser to render an entire page, or how long did it take for the page to be like fully interactive. Whereas protocol level, so that's the most commonly used case, let's say for load testing API. So with protocol level, rather than using like a real browser, we're using protocols such as HTTP to, like simulate a bunch of load. So we're interested in testing like our server response times and ensuring that when multiple requests are sent from different users like simultaneously, that our backend servers, that our databases should be able to handle that load. When it comes to like load testing, obviously protocol level is like a really popular choice because it's less resource intensive. Because if you think about browser level and load testing, even though with XK6 browser we now have that capability to spin up browser like virtual users, we still need to consider that with browser level load testing, that it could be quite resource intensive, because we don't really want to spin up like 1,000 browsers just to simulate like a load test, because that could crash like the servers that we're using. So we have to have a balance of doing browser level and protocol level as well.
Right. And that's something that we kind of see a lot, in that in testing, it can not be as real world as it may be in production. Right. And so it sounds like, as when you have kind of the separate metrics as well for browser and protocol, and you're testing them both, then you can also maybe be able to better identify where there are bugs or understand where issues may arise, because you've already put it through its paces, so to speak, in a test environment. And so if something goes wrong in production, you can go back and you can evaluate that with that context already in place. Have you seen that be a benefit as well?
Definitely. So, one of the use case that I've mentioned during the talk is that the real power that, for example, that we're trying to communicate with XK6 browser is you can now simulate, for example, you can run a bulk of your load testing on a protocol level. So let's say you want to create like 1,000 protocol level requests, but at the same time, that wouldn't give you an insight to your user experience. So let's say you want to check if any loading spinners are taking a long time. So what you can do is, while you have like 1,000 load tests like on a protocol level, you can have a couple of browser level virtual users just to check the overall user experience as well. So you can now have, I guess, the full picture when it comes to performance, because rather than having an isolated approach, you can then check, oh, what's happening in my front end if my back end is exposed to this like amount of like high number of requests.
Yeah, and that sounds similar to actually kind of going into this next question from the audience. You may have touched on this a bit, but it states that there is an overhead involved in diagnosing CI failures, for a single use case in end-to-end testing. With the K6 backend, you have access to the CI report, and you can see failures and checks and thresholds. But knowing that you may or may not have a CI diagnosis tool like Replay or Cypress Dashboard, when you have the K6 browser extension's CI diagnosis issues, how can you make the CI diagnosis aspect of that easy or easier?
That's a really great question. And I'm not 100% like closer to it yet because XK6 browser is still in a very early like beta stage. But one of the things that I know that the team wants to achieve in the future is that in within K6 Cloud we have a feature called performance insights. So it can give you insights as to which area really has the high number of like bottlenecks. So if your CPU has experienced like a very high number of like utilization, then that performance insights will be able to tell you that maybe you can try adding some think time, adding some sleeps in your test, because again we want to simulate what's happening in production as closely as possible. So we're still doing a lot of like beta tests in our K6 cloud. It's not like open yet, to like the wider public, but that is something that we would have. So it can then give you some diagnosis as to like which areas have like a really like performance like bottlenecks issues. So we currently have that with like with the existing K6 stuff already. So with the performance insights, it gives you information as to which, for example, servers have like degraded because of the high number of like load that you run. So we want to use, or we want to have the same sort of feature for XK6 browser for that. But for now, it's not like fully out yet in the public.
Well, it sounds really interesting to be able to get those kind of insights from a CI environment. I know that's something that we all struggle with, is understand what's happening in those spaces. Another question here that we have from the audience is a question about the resulting output. So is there any way to configure alerts when certain metrics increase?
Yep. So you can use thresholds for that. So what you can do is, let's say like one of your SLA is, a specific like response time should be less than let's say 500 milliseconds for like the 95th percentile. So in K6 we have a concept of a threshold where it's like a pass fail criteria. So if the threshold fails, then your test will be reported as a fail. And then in terms of like notifications, I think there is actually an extension that one of like our K6 contributors have written. I have to come back with the actual name, but because I've seen that there's like a list of extension in our XK6 ecosystem that you can use it to send notifications to, I guess, like whichever like sort of like platform you want. But yeah, the way to do it with K6 is you have to configure a threshold, and then after the test has finished running, then that specific threshold will then say if it's meet the criteria or not. Yeah.
Okay. And that probably helps with establishing your metrics too, because you assign those thresholds in advance and everyone's on the same page about what, acceptable performance is. So that's always a good discussion to have. Another question here is, can you test Kafka producers and consumers with K6?
I believe so. So we do have a K6 extension if you want to load test Kafka producers, consumers. I would have to refer you to one of my colleagues because my main sort of expertise is around browser automation. But yes, we can load test Kafkas as well.
Okay. Yeah, there's a follow-up question about whether you can fire custom events directly and test how the system reacts with Kafka producers and consumers, but maybe that might be a better question to hold off on. So
I can. So if this person maybe send me a message, and then I can give you, or I can point you to the right person from the K6 team who can be much better suited to answer.
Yeah, absolutely. So we do have a very important question here, which is, which character do you main in Overcooked?
Which character did I?
Yes.
Did I make?
So
or?
Yeah, which character do you like to play in Overcooked?
Oh, I don't know any of the names. I just let my daughter pick like any random ones that she likes, but normally it's like the cute animals. She doesn't like one character who looks like this angry chef guy, so
Oh
we
yeah.
tend to avoid using that character. But yeah, it's like a really interesting game because it's supposed to be a cooperative game, but playing with a 5-year-old, it's like very stressful, and which is why I wanted to relate it to my talk about load testing, because once the orders have started to pile up, we can relate that to if you haven't tested your servers properly, you just get like a lot of queues, a lot of requests that haven't been processed, and ultimately it results to a bad user experience.
Absolutely. I've played Overcooked as well, and it requires a lot of communication, right? Between, if you think about the front end and the back end, it requires a lot of communication between you and the other person to really be able to handle that. So it's I thought that was very fun, but awesome. So I don't have a main character either. I just kind of pick different ones. So
Yeah.
so I guess back to another question about K6. What was the main motivation for introducing the XK6 browser?
Yeah. So, um, I think just to give everyone some context, so we have this, golden rule of web performance. I talked about it during, my talk as well. And basically, it's saying that 80% of like bottleneck issues actually happens on the front end. K6 stayed away at the beginning, away from like real browsers, because they want to make sure that back-end performance testing is like very stable. And I think now that K6 has definitely reached its peak maturity, it's now like very stable, we now have a lot of support from the community. We now want to shift our focus on front-end performance testing, because we know that in order to have that hybrid approach to performance testing, we can't just do protocol level, we have to do both. So the main motivation really is to make sure that we get, or we provide our users a way of having a full picture of your application's performance. And I guess you can do that already by plugging in like different tools, by using different tools, but we want to see if we can try to have a single tool that can do that, that we can use like the same script, and we can use, or we can leverage the existing features of K6 that our users are already using. And now we just want to focus on highlighting more of the front end performance side as well.
Oh, that's great. Yeah. And thank you for providing that context. So when it comes to other kind of tools or testing tools like Playwright and Cypress, how does the XK6 browser either, compete with or complement or work alongside those types of tools?
Yeah. So this is a really interesting point for me, because even when I started K6, so we have this thing called Week of Browser Testing. So one of the things that I've spoken about is we don't want to compete with Playwright. We don't want to compete with Cypress, because the messaging that we want to share is we want to provide a hybrid approach to performance testing. Yes, you can do performance testing with Playwright. Yes, you can do performance testing specifically front end with Cypress. But what if you want to have the same tool for back end as well? Then you would need to use like other tools. So the angle that we're trying to communicate here is like, if you want to have a single tool for a hybrid approach to performance testing, then XK6 browser with K6 can help with that. So we're not looking to compete. We're solving a different, I guess, problem that our users are facing. And I guess the more tools we can provide to our users that can solve the problem, then I guess the better it is.
Right. I guess the answer is always it depends, right? It depends
Yeah.
on the use case, the product that you're testing, everything like that. So you can go ahead, attendees, if you do have any additional questions, you continue asking those on Discord in Q&A production track. But we'll go ahead and wrap things up there, Marie. Thank you so much for answering all these questions and for your really great and interesting talk. I know that I'm definitely interested in checking out more about the K6 browser and performance testing for front and back end. So thank you so much, Marie. Again, you can continue to ask questions of Marie in the Q&A production track channel on Discord.
Thank you so much. Yeah.
Great. All right, next up we have Anurada.
Thank you, Cecilia. So before moving ahead, let's give a big round of virtual applause to our platinum sponsor, Sauce Labs. Sauce Labs offer the leading test and error reporting solutions that identify issues across the software lifecycle, giving the visibility and insights that enable its customers to achieve high quality and high velocity releases with confidence. So, also join today's discussion room, which is on testing complex architectures. It starts at 5:10 p.m. Central European time, and it will be taking place in a special chat. So just a reminder, feel free to go ahead and attend this discussion room. And now it's time to welcome our next speaker on the production track, David Burns, who is going to share with us 5 habits to treat your test code like production. David Burns, who you might also know as Automated Tester, heads the open source office at BrowserStack. He's also a core contributor to the Selenium project and chair for the W3C browser testing and tools working group. And today he will be talking to us about 5 habits to test the production code. But before that, David has a question for you all. So go ahead, open your Slido, put the code 0304 and answer this question. Do you do other items of testing in your component testing, like visual regression testing, accessibility testing, performance testing? So go ahead and fill in your answers, and we will be talking with David about the results of this poll. So also do not forget to put the questions in Q&A production track. And with that, everyone, let's make some noise in the channel and give a big round of virtual applause to David. David, the stage is all yours.
Hi everyone. Today I'm going to be talking about the 5 habits to treat your test code like you would production code. So first of all, who am I? My name is David Burns, or as most people tend to know me, Automated Tester. I head up the open source program office at BrowserStack. I'm the chair of the browser testing and tools W3C working group. I'm a Selenium and a Nightwatch.js committer. I've been in this industry for a while, and so hopefully by the end of today we're going to be able to kind of take something away and see how you can rejig everything you do at work so you can make your lives actually easier. Here is our agenda. I'm going to look at how people tend to look at their testing on projects, how we can break down testing to make it manageable, maintainable, and less flaky. That's the most important part. How to treat your test code like production code. So what we do with the last part, and how to improve your tooling, and actually why this matters. You'll be surprised. So let's get started and see where we go. Now, I've been working in testing for many, many years, and I tend to see how people look at testing from different ways. And if we look at it from the textbook way, this is how people should be doing it. Right? At the bottom, we have the testing pyramid here. At the bottom, we have unit tests, right? The reason why that is wider is that there should always be a lot more than that. A lot more of them than any other tests in our test code. Then we have service tests. These are our integration tests. These are all kind of like, if unit tests are small, Service tests tend to be medium and kind of start bridging gaps between all our little components of code, or like atomic areas of code, and starts getting us towards the next part, which is our UI tests. Now, one of the things I didn't put in here is manual testing. Generally, I tend to speak about automated testing, but this is not to take away from manual testing. And if you have a look at the arrows on the side, is that you've got on the left hand side, or as I look at the screen, more isolation to more integration. So the higher you go, the more integration you're going to need and less isolation. The downside of when you add more integration is that things will get slower. This is just general computer science, right? The more code that has to be processed, the slower it will be, right? If you do a loop within a loop, you know that's going to be slower than kind of a single loop trying to find something. And so ideally, we need to be trying to make super fast tests and a lot fewer slower tests. Unfortunately, especially from what I see, and I appreciate there might be a lot of bias, having worked on Selenium and Nightwatch.js for many, many years, is that people do unit tests. These are generally done by your developers, and they're done in like with Jest or kind of Karma or things like that, and people will put a lot of effort into them. Then you'll start getting some service tests or these integration tests. And so I took my image here from Martin Fowler's work, and I've kind of rejigged it a bit. And then, especially now that I see this in Browser Stack and kind of speaking to customers, and when I was at Mozilla kind of speaking to Selenium users, people tended to throw everything, and I mean everything, at their unit tests. They would bulk it up, put tons of tests, and then slowly but surely the tests would become unmaintainable. A developer would make a change to the UI, a designer would help, and then suddenly whole swathes of tests would start failing. And then obviously, who gets the blame? The testing tool, not the people who've architected the code or architected the tests. None of those people. It is purely down to the test framework. You and I know that's not right, but that's generally how people react, right? And they put tons and tons of effort into the UI tests. And then suddenly they're like, I don't have time to be writing UI tests. I've got to do these manual tests so that I can kind of work out what I need to do. And they build it and build it and build it. And then they try scale it horizontally because their UI tests are taking a day to run. We all know that ideally the CI should be done and dusted within 10 minutes, right? That is the gold standard. Always try to get all your tests within 10 minutes so you can have that fast feedback loop, because I don't know about you, but whenever I write code, if it doesn't always work, and I will hold my hands up. I write a lot of code, I write a lot of bugs. Fortunately, I tend to write a lot of tests to go with it, and sometimes they work on my machine and then they go into the CI and they stop working because there's certain assumptions. But we need that gold standard of really fast tests. And if we're bulking everything up in the UI area, then it's going to be really, really slow. So how can we get around that? Well, let's make our tests a lot more modular. So we know of small tests, right? Or unit tests. We know about integration tests or medium tests, and we have these end-to-end tests or large tests. The thing is, end-to-end tests aren't always needed. We know that if there's a form, you can test that form in isolation. It doesn't need to be an entire workflow. you can build out these things, especially if you're working with your front end team who are building these modularized components to move things forward. And so we need to pick the right test, just like you would pick the right architecture. I know that from working with loads of people to write tests, is that if you're writing some code, you're not going to have one monolith of a file and then ship that into production. And I'm saying this is not your obfuscated and minified code, right? Obviously that is going to be one file. But when we're building up to that point, you know that if you want to find certain things, how to structure your code. Unfortunately, people don't always do that with their testing. They don't know how to architect it. And this might seem controversial, but this is why it's important that your SDETs, or your software developer in engineering, software development engineers in test, take that time to know what they're doing. Don't throw a junior at it and go, this is your problem. Don't throw him a exploratory tester. Treat your SDETs like you would your software engineers, from pay to recognition, and you will see huge improvements in how your code and your tests are formatted. So, we know we're not going to create monoliths in our production code when we're writing it all out before it goes into our build system. So don't do it within your test environment. Every good presentation needs a good meme, right? Split up your tests. If you're testing small modular parts, split it out. Make sure that you can run each and every test individually, just like you would if you were splitting out your production code, right? People go, yeah, I can split out my code. I know how to break this down, right? You say the same for tests and they're like, it's a test, why does it matter? It does. It really, really does. And this is why we need to get into this mindset of kind of like, whenever you're writing code, you're writing code. Be it an automated test or production code, right? Or anything in between. Code is code. Your SDETs are engineers. They write code. Your software engineers, they write code. They're exactly the same. They look at the problem slightly differently, but they still look at the problem. And so it's important that we make sure that when we're breaking these things down into their individual parts, that we do so in a meaningful way. So we've talked about this, where we have our unit tests, our service tests, but that big bulky UI part, we can break that down even further. Right? We don't need a full end-to-end test for our UI tests. Yes, we might need a browser, and it's important to make sure that we test in all browsers that our users use, right? If you're going to test in Chrome, test in Chrome. Chromium's going to react slightly differently. So you're not going to, if you test in Chromium, you're not always going to get the same end experience that an Edge user would, or a Chrome user would, or a Brave user, or an Opera, or Vivaldi, right? It's all the same browser under the hood for the engine, but not always going to give you the same result when you're moving things about because of the way they configure it and ship it. Same with using WebKit. WebKit might be the underlying tool and engine for Safari, but there are times where Safari will act very differently to WebKit, and it will act very differently to iOS Safari. So always make sure that when we're breaking these down, that we break them down and then we test where our end users are going. Because that way we can know that we've done the right job. Now, by splitting out things into these slightly more manageable parts, we are going to remove flake. The smaller you make your tests, the less flaky they will be. Now, I'm sure you've all tried to write end-to-end tests, and a lot of the times you need to align a lot of stars to make it work. Your database needs to be set up, your middleware needs to be set up, all your front end needs to be working, and whenever you do something, it needs to be able to pass through all these layers and then back again. And being JavaScript, everything is asynchronous. So you need to align a lot of stars to make things work. Sometimes it'll work, and you have means to kind of test things. So working on Nightwatch.js, which is built on top of Selenium, it does all the auto waiting for you to be able to know when things are. But you need to know that that thing is going to be there. And so we need to break things down, make them smaller, and we're going to be breaking down the UI tests. Because the UI tests, the end-to-end tests, take too damn long to run. Right, let's be clear. It's not good enough. And so how are we going to split it down? I keep saying it, we need to split it, but how are we actually going to be able to split it out? I've got an example, and let's go have a look at it. So here, here is a small test, right? It's really, really small. And I recommend to everyone who writes tests, especially end-to-end tests, that your tests do 3 things at most. They start from a good known place. They do one thing, but one thing very well with an assertion. If it's not doing an assertion, it's not a useful test. And then it knows where to go back to. And so in this case, I've got some demo code here. And let me just make it really big. And I will zoom in so you can read it. Here we've got some component test. We have a React component that I'm going to load. And if you want to see what it looks like, it just looks like a standard React component. This one's a form for a to-do list. So it takes everything, it has its inputs, has some change status, and it has a submit button. Really, really simple, right? And everyone can see what it is, they can work with it. Everyone's worked with React, so I'm pretty sure nothing of this is a shock to you. But the thing here is that we're able to write a test to be able to kind of load a component. In this case, we can expect it to be visible, that we're going to work with it. Now I've done a really simple thing here, but we could simply just break it out and do stuff. So like, because it's this is a Nightwatch test, it's really simple. It's got a nice fluent API, so you can work with it and you can do more things. So you could kind of go await browser find element component and break it down and then move into it. If you wanted to type stuff, you could set value. I love cheese because I do. Oh, and that would work. You'd be able to interact. And now instead of a whole end-to-end test, right, we're not going to check that we can send everything all the way to the database. Those tests are still useful, but we need fewer of them and a lot more of kind of these small modularized component testing. And we can just kind of use the same components that we've been using as before. So it's really, really simple. Um, the other one that I think is important that people focus on is making sure that once you've got your test working, that you keep all your items up to date, all of your npm packages. So in this case, I was, like for my example, a new Gecko driver and a new Nightwatch was released. npm outdated needs to be used on all of your test dependencies all the time. Keep it regularly updated. Ideally, set a bot to do it. This is just busy work for a person to do, and so you should use bots where possible. And we'll get to that in a second. But make sure that at least you run npm outdated once a sprint at your work, so you can keep things up to date and you can start using new features straight away. Like with Nightwatch, we ship Selenium under the hood, and we allow people to kind of do really cool things like network interception, basic authentication handling, JavaScript console error messages, capture, so that you can fail tests if your JavaScript's not very good. Or if you wanted to look for certain mutations on the page, you could set that all up and be able to do it. And those things regularly come out and they get updated, and it's important that you keep your test dependencies as updated as your production ones. Don't go, oh, it's a test, it doesn't need to be updated. There are good reasons why those get updated regularly. And this is a good example, right? This is the versions of Nightwatch that are out there, and we have people all over the spectrum. And so I've just taken a very small snippet of our user base. And so it's important that you keep things up to date. I appreciate some projects never need to be updated, but then if you're not updating the production code, then you're not going to update the test code, so be it. But if you're making updates to your dependencies in your production code, make sure you do that to your test code. It's important. And then finally, have tooling that keeps you in flow. I use VS Code all the time. And at the minute I need to leave VS Code, I know for me, I can easily get distracted. So try find tooling that keeps you in flow, that keeps you working, keeps you in where you need to. So as I've said, I work on Nightwatch. Nightwatch has a VS Code extension to be able to run tests, so that all I need to do is click a button, I move to my tests, I can run them. I can run them against different environments. I can run my component tests. I can run everything all from where I am. The minute you need to learn new commands, new things, it keeps you out of flow. So try find that tool that keeps you where you are. It helps you test your components from the start and then keeps you in flow. So flow is that when you're working, your head's down, you're working hard and everything's all right. So keep at it. And that's it, folks. I hope you found this really useful. As I said earlier, my name is David Burns. I am the automated tester. I work on Nightwatch and Selenium. And if you have any questions, you can find me on social media or kind of Discord or Slack. And I'm happy to always help out. Thank you.
That was a pretty interesting session. Thank you, David. Testing is often overlooked, but I'm sure that now you learn something to treat your test code like production. So David will not be joining us for the Q&A right now because he's facing some connection issues, but we are trying to sort it out. In case it works, then we will be back. But till then, we are going into a break. So go ahead, take a short break. And if we are able to fix the connection issues, we will be back with David for Q&A. But also, meanwhile, you can still ask questions on the Q&A production track to David, and he's going to answer once he's available. So see you all in a bit. Stay tuned.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Hey everyone, so David is with us and we have figured out a way to talk to him. So yay, so I will be inviting David over to stage now and yeah, hey David.
Hello, everyone, and I'm so sorry. A family emergency came up, so I've had to deal with that. But I did try my best to join, and I have. So sorry about that.
No, thank you so much for joining despite having an emergency situation. And first of all, your talk was really great, and I am sure people took nice habits to treat their test code like production. So you had a question which we asked the audience before your talk is like, do you do other items of testing? So the answers are like visual regression testing is at 62%. And accessibility testing is at 38% and performance testing at 37%. So what do you think of these results?
It's kind of what I was expecting. It's something that I've been looking at recently, and I was very curious to what people would be doing. Visual regression testing is kind of big at the moment. So yeah, it kind of matched with what I was expecting. So that's good. Like at least my gut was kind of correct, right there.
Awesome. Although it would be nice if people start doing more accessibility testing too. But
definitely,
yeah.
most definitely.
Yes. So we have questions for you. First question is, what components do you work with first when testing, I guess? Yeah. Which components do you work with first?
So yeah, so in this case, like I think it's how people break it down, right? Like so, like you know, with your when you move to production code, right? Like you try to go for the smallest piece, and so whatever you can get to that point is the area that I think you need to focus on. And so if you can, like I know a lot of people look at things like Storybook, whatever, right? Like it's all about like treating code. Your test code as production code, right? And so like if you're going for component testing, you go do that and you look at your components, you break it down and then like to the smallest part and then you extend it outwards. So that's how I tend to do it. I don't kind of have one area that I focus on, but I find the one that's the most important, the best business logic, things like that.
Yeah, awesome. Yeah, I mean, definitely. Ebster asks that what are the good practices for snapshot testing?
so I have multiple feelings around this, and a lot of them actually conflict, which I find quite interesting. So like going back to like, so snapshots, you should always like try make it do the thing that you think it's going to be doing and keep it at that, right? And then something I've been working on recently is trying to extend some of the projects I'm in to work with NX, the monorepo tool. And so that uses a lot of snapshot testing. And there's times where I just like, I've got to focus on this, do this right. And then there's times where I just go, I'm just going to rewrite everything and just overwrite snapshots. And so I lose the value in it very quickly. But then at the same time, like I also use it to go, oh, actually, I've messed up big time. And so that's how I tend to do it. It's the same with like visual testing. Like I take my snapshots and then sometimes it's like, actually, I just want to rewrite everything and throw it all away because it's just frustrating. And so that's where like I find it useful. And then at times I find it frustrating. So I have these conflicting things in my own head. So it's hard.
Yeah, I mean, certainly. For me, I think when I hear snapshot testing first, I actually go into just snapshot testing, which we used to do for React. And so when we started first, we were like, yeah, we should do snapshot testing for everything. And soon it becomes too heavy to maintain because you are doing any change and you just blindly go ahead and just run -u and update the snapshot. Like most of the people, I don't think that. Yeah, so there is no practice in like people really going and seeing if the snapshot broke, why did it break? So maybe it kind of counterfeits the process. What was the reason of snapshot testing? But yeah, again, conflicting reasons as you said. So there is another question. Why do component testing when you can do end-to-end testing to check the things?
Yeah, so this is my favorite kind of thing at the moment. So at the beginning I said like, break down your code, break down everything so you be driving it forward in the smallest amount of bits, right? The thing I like about like doing that and then treating your code as production and then which has led to this whole belief in component testing, which I'm 100% behind, is the idea that you can kind of just go, I'm going to do this small bit, make sure that this small bit is correct, which is going to be super fast. Because like having worked on browsers, the thing that I always noticed is that like a lot of people struggle with like concepts like asynchronicity, right? Even if you do JavaScript in and out every day, right? There's still times where JavaScript will just go, I'm only going to reply now, right? And you've been waiting, or you've written this like callback hell, or you've got these like promises that are super nested, and you're like, okay, no, this is not going to work. And so we're breaking it down. So you would in production, right? Making sure your tests are in specific files, your tests are doing the same thing at the right point, and like you're not just focusing on one too many of different things. You kind of then get to this ability to run them quicker, right? Super fast. And then if you want to do your accessibility testing, your visual testing, right, they're going to be even faster than if you did like an entire page, right, to do your tests. So it's all about the speed that way.
Thank you. So I had another question, which is like you talked about tooling, right? Like we should be keeping a tooling which keeps us in flow. So do you have any preference of tooling? Like what kind of tooling you use when it comes to UI or integration tests and so on?
So I try to so tooling wise, I don't use too much. Right? Like I'm a visual code developer. Like I develop in visual code. No, I don't develop visual code. And so I find all the things that I need are important to keep me in that space. So I find the extensions that do those jobs for me, right?
Oh.
The minute I feel like I need to go out of something, then then I see little value. So I don't have a specific tool, but it's the tool that I find useful for the task at the time, and then I try optimize around that. And then kind of, so it might be like simple things of just like learning not to use your mouse, navigating just by keyboards if you can, because then you get a lot more speed, a lot more flow, and things like that.
And you can also test for accessibility.
Exactly. Definitely.
Yes. Thank you so much, David, for joining us today again. It was a great talk and for being there for the Q&A despite all the hassle. Thank you.
No, thank you, everyone. I hope you enjoyed it. If you do have any other further questions, you can always just message Twitter or anything like that. I'm happy to help.
Thank you. Bye. So, and this was David for you all. And now I'm going to pass on to Valmir.
Thank you, Anuradha. So I'd like to thank our gold sponsor, Stockhawk. Stockhawk makes it easy to automate applications and web security testing with your CI/CD pipeline. Find and fix security bugs before they hit production with stackhawk.com. And our next speaker is Florian on his talk, Testing CLI Utilities. And now let's meet him then. Florian is a solution architect from Germany who is specialized in the creation of scalable distributed web applications. These days, he's almost exclusively working on micro front-end solutions. He even wrote a book about the topic and regularly gives workshops at conferences and directly for companies. But before we go with Florian's talk, he left a poll question for you on Slido. So go to slide.do and use the code 0304. And Florian is wondering, what does CLI stands for? Is it from custom line interface, command line interface, computer line interface, or is it camel, lion, and iguana? So don't forget to go there and answer the question. And also don't forget to ask questions on Discord at the hashtag Q&A production track. So let's give a big round of virtual applause to Florian. And Florian, the stage is all yours.
Welcome everyone to this session, Testing CLI Utilities. I hope you are as motivated as I am to get started. Before we begin, let's have a look at my person. Hi, I'm Florian. I'm a solution architect at a smaller company based in Munich, Germany called Smartpjot. We're mostly doing IoT and embedded computing, and we are specialized in building digital transformation projects, especially using distributed web applications. Also, I'm an open source enthusiast. What does that mean? Well, I've been awarded a Microsoft MVP in the area of development tools for the last decade. I spent most of my time doing projects in .NET, JavaScript, TypeScript, web development space. I'm writing a lot of articles, and I've also written one book already about micro frontends, and I'm currently writing another book about development of frontend applications with Node.js. So be sure to get a copy. But enough about me. Let's just jump right into a topic before we run out of time. So CLI utilities, what makes them difficult to test? What makes them also appealing to test? Well, first of all, I mean, CLI implies they're running the command line. So this is on the one hand good, because spawning a terminal process is always quite easy, and in some sense also easy to work with, much easier to work with, for instance, a graphical user interface. On the other hand, of course, you need to deal with some things like, for instance, receiving the standard output, or also placing some inputs on the standard in stream. And you, of course, need to coordinate that and have your asynchronous processes right. CLI utilities often provide, let's say, kind of an intersection point between two parts of an application. So they are quite important to test, to get right. And we are relying a lot of CLI utilities. So, I mean, having them working reliably is, of course, always what we strive after. Anyway, these CLI utilities, like any other application, they might also access some resources. For instance, of course, network resources. And yeah, I mean, you may want to mock these. You may need to run local services, and you may also need to coordinate these resources. So that's something you need to keep in the back of your head. Also, of course, with each step that you do in a mocking direction, of course, you remove a potential source of error for a later run, and you will need to accommodate for that. The most important area, though, is, of course, what happens locally on the system. So, for instance, on the file system, read and write operations need to be sandboxed properly. If you run especially multiple tests in parallel, you can't just go in blindly and say, whatever these utilities that I'm testing are doing, I just trust them that they always, of course, work in, I don't know, dedicated directories, and that there are no race conditions or whatever, really running them in parallel. And that, of course, applies to any kind of system resource that they access. So you've got already a set of challenges, but also a set of things that, you know, make CLI utilities particularly interesting for testing. Right, so going a little bit further and thinking about some challenges that arise in that, we've already heard about input-output. Serving content was already briefly touched. But just to remind you, so for instance, let's say what we will be testing is so-called PyCLI. It's a little utility that helps you with a couple of web development related tasks. One of these is scaffolding, but another one that you would do quite after the scaffolding is running, for instance, a debug process with it. And this debug process is actually opening a web server on your local machine. Now, we want, of course, to verify that this has been opened successfully. And so, of course, this part of the CLI that it opens some port is something that we need to consider. Now, how do we ensure that the correct port was opened, but also then, of course, that the output served on the port is right? You need to, of course, have all those questions answered. In our case, what we did, of course, is we ensure we are just some ping on the port that the port is alive. But then afterwards, what we can do is using utilities such as Playwright for actually accessing the content, reading out it, and verifying it against, let's say, an expectation source that the actually served resource is the same. Now, fragmentation is something that will appear quite often, which means that a CLI utility might, let's say, place content that it, for instance, creates in a couple of directories. And you don't want that to happen so often because, first of all, you need to clean up after each test. And second, you need to ensure that the test, of course, stays isolated, right? That you can run, for instance, multiple test cases in parallel or multiple test suites. And if, you know, you don't have control over where the utility that you want to test is placing files, you might run into these race conditions that I mentioned earlier. An additional problem that will be potentially even the main challenge that you will face is performance. Now, if, let's say, running one test case will be like 30 seconds because you need to scaffold and create a lot of files, well, this might be acceptable if you just have this one test, but if you think you have 100 tests or even 1,000, then 30 seconds is certainly not at all something that you can accept. And so you need to think about how can you improve performance here? How can you make it that on average, I mean, maybe still one test case takes longer, but on average you have, let's say, times between 1 and 5 seconds the most. And so you would need to think about how to structure that really efficiently. And one strategy is, well, to use temporary directories. Important part here is that these are directories that you will create. There's another strategy where you create so-called OS temp directories. So they're coming from the operating system. And the big difference is that when you create them, you actually can define where they are placed, which makes a lot of sense because after all, if the operating system decides where this temporary directory is hosted, well, I mean, first of all, they get a little bit out of your sight and they may be quite substantial in size, but that's maybe acceptable for a while. But worse, you don't see so easily where that output was placed. And therefore, of course, for instance, in a CI/CD scenario, you can't just, publish them very easily and see later on what was actually happening in that directory, why did the test fail, or when it succeeded, that you can make a manual verification that all your, let's say, assertions in a test are really useful and working. Anyway, what you can do with this is when a test starts, like test 1 here, it just creates this temporary directory in a known location, and it works in this directory. And you're good, and you do the same thing with a second directory, and maybe even a third one. And so far that is looking quite fine, right? You still need, let's say, some primitives that you always, of course, refer to this temporary directory and not just let the utility do whatever. So the context, for instance, the working directory, to start with the simplest one, must be set correctly. But still, you've got a lot of overhead here. And that's why all these 3 tests here are placed in the same test suite. If they share, for instance, a common template where they should work against, they would need to redo all the steps. And so maybe even more efficient way is to add something what I would call a file system cache on top of it. So the strategy that you do here is the following. You start with your test suite, and when that starts, it will create what I would call a template directory. So all the steps that each of your tests will require will be already done in the template directory. Now, the trick is that when you create a new test, it will first, before it runs, create a temporary directory, but make a copy of the template directory. Now, that could be even as efficient as just symlinking that, which means you have essentially no overhead. Every file that appears in this temporary directory 1 will be just symlinked, so there is actually not even overhead on the file size counter. But of course, there might be problems here. So if your utility, for instance, writes, symlink might not be the right choice. You can mix, but in our case, for instance, we are doing a lot of modifications. The simplest was just to copy, and the recursive copy was still much faster than following the templating steps. That being said, once the temporary directory is there, you can just refer to it and your test can run. And you do the same, for instance, with test number 2. So the directory is created and then refer to it. And same, of course, with the third test. Before the test runs, the temporary directory is created and it will already get all the contents in there from the templating. And so no scaffolding steps are required. You just run your tests and all is good. Another advantage here is, of course, that you got it very reproducible, right? So the first run of, let's say, the test 1 might take a little bit longer, but then 2, 3, and even more tests, they will all just use the temporary template directory. And so they will be really speedy, and we will see that in the demo in a minute. Now, what about the serving content part? What you can do here, instead of just triggering, I don't know, creating, for instance, a server on the fly, you will actually wrap all these things in little objects that you could call a service, right, as well. Now, a service in your JavaScript code, for instance. And instead of just firing up a server, like an, I don't know, HTTP server, for instance, you would need to go through a port allocator beforehand. Now, the job of the port allocator is to make sure that you don't just select a fixed port for it, let's say 8080, but that you get a port that is free, right? Because thinking about, having multiple test suites running in parallel and both are running a test case that demand the same service, if you would fix that port, let's say to 8080, then you would have a potential conflict here. And even if you, for some reason, have some logic in your application where you say, oh, depending on the test case, I just increment a counter, well, that might fail as well, right? Because you don't know where you're running this test. From a CI/CD system, for instance, you don't know what ports are available. So it could be that 8080 is already taken there, maybe 8081 is available or something else. So that port allocator needs to be sure to dynamically get you a port that's really there. And it will reflect it back. And so you can then open, for instance, an HTTP server on the respective port. So quite nice. You put then the resulting instance into a resource manager. That's quite handy for later on. And then, of course, your test case might continue, might create another service. Same principle here. It will be put into a resource manager. And now the resource manager, when the test case finished, it will have the responsibility of cleaning that all up. But that is implied here. So there's no manual step needed, which can be quite handy, especially if you, let's say, forget about taking care of, for instance, failing assertions and such. So you might have even a problem in the code of your test case. And even in such cases, you want to reliably shut down these services. And the resource manager just does that. So it's always a good strategy to have such cleanups just implied and handled correctly out of the box. So in our case, what was the basic setup then to run such tests was actually, I would call it fairly straightforward. We were using Jest as a test runner. That's always a good basis because it provides a lot of convenience. Also command line arguments can be supplied to, for instance, just select a certain test and you just get a full ecosystem already at your disposal. Next thing, we were using Playwright because, as mentioned in the one example, we had to verify output in a browser. Just verifying, for instance, that some HTML is served was not enough. We wanted to see that a rendering is working, that really this HTML is, for instance, loading some JavaScript, and that this was doing the right things after all. Then what we were using to write the test was TypeScript. I wanted to be sure, of course, that we have no bug or issue already in our tests itself. So that would make debugging even more brutal than anyway fixing some failing tests. And we were running everything in Azure pipelines to have it continuously being verified and monitored. Now, putting that all in a diagram looks like this. Our CI/CD system triggers daily 4 o'clock in the morning. It runs the tests. These will be matrix tests, more on that later. This would just start a Node.js process running Jest, and Jest then interacts with our tests that have been written in TypeScript via plugin or transformer called TS Jest. Now, these tests might use Playwright, they might use other resources, whatever they do, all the interaction is now from these test cases. And at the end of the day, Jest writes out a JUnit formatted file that can be then published from the CI/CD pipeline. And that allows full inspection from Azure DevOps, their web portal, but also, of course, via an API. So it's quite convenient, quite nice. You can have automatic reports. If something is failed, you get notification via email or in your favorite channel, for instance, on Teams or any other system. But that's quite cool. How does then a test look like? Here's an example. What we did is we wrapped the normal test suite definition just for convenience. So you then just start this as you would do normally in Jest, but what you get back is special functions like lifecycle, like setup, for instance, but also a special testing function. Now, the advantage of that approach is that in each of those functions, we have this wrapper running and we can then access a context. Otherwise, we have certain parameters which are all placed in the code via environment variables, so they can easily be set on any machine. They are set, of course, in our CI/CD pipelines. And here you see, for instance, what we do to test different versions of our CLI utility. By default, it will always use the latest version, but you can actually set it to a different version, a preview version, for instance, which might be interesting. Or if you want to see that, there's a regression happening, did this already work? You can make a new test case, but run it against an older version too, of course. And this is all covered, of course, by such parameters. Otherwise, this context, of course, ensures that whatever you do, like running, for instance, spawning another command line process, you will always do it in the right context. So, for instance, using the right directories. So here, there's a lot of magic implied behind that. But rest assured, the most important thing that it does is it sets just the current working directory to a temporary directory already settled. And as you can see, that's the advantage of this wrapper. You don't even see the creation of any of that. It's just happening, and it's reliably happening, and all these resources are managed under that context. So that's all not, let's say, a publicly available framework. All the source code is publicly available, but it's not, let's say, a library that you can just have. It's just tailored to our solution, but you can have a look at the GitHub repository for it. Right, so what is this test context about? That's the TypeScript definition. Most importantly, everything is asynchronous. So even the things that are not called something async are asynchronous. For instance, if you run something, you get back the promise, and that promise resolves when, for instance, this process that you started has completed. So the string that you get back is actually the output stream. Now, if you use, in this case, run async, then you get back the running process and you will need to explicitly, for instance, wait for it, and you can then interact with it much more nicely. And you also have everything always being made relative to a temporary directory. So for the file, you don't need to know where the temporary directory is. You always just supply relative file paths, and they will be automatically mapped to the temporary directory, which is great because that means there's really no need for a developer doing these tests to have any idea where the files will be placed. It's just automatically happening, and you can just focus on what should be now inside this structure. Right, with that being said, let's have a quick look how that looks in practice. What I see here is one test suite that we have for testing a specific subcommand of our command line utility called pilot build. So each test suite we have for a specific subcommand. And what you can see is just in the example, we have a setup function here, and that takes care of these templating steps. So in this case, it runs quite some steps. It first, starts our CLI to actually prepare this directory, but then it even installs some bundler, and it even installs some kind of other dependencies. So it runs, in our case here, a couple of times npm install. So it does that to actually prepare everything as we want it to be for running the test successfully. And then later on, when we actually want to run a test, we just use this test function, and we run the command that we actually want to assert is working correctly. So in this case, it's called pilot build. We run it via npx just to make sure how the end user would run it. And once that's done, we can make assertions on the files. So for instance, in this case, we're only interested in what's happening in the dist index.js. One could argue you could do such things also with snapshots, and we experimented a lot with snapshots. In the end, what we found out is that snapshots are, at least for the utility that we have here, are not good because we would need a lot of exclusion rules. And even without these exclusion rules, a file like this index.js is highly dependent on all the node module dependencies that have been installed. And just a slight version in any of these dependencies, slight change in the version of any of these dependencies might have an impact on that file. So what we do instead is we just identify some key points that are definitely needed to be in this file, and we have them here in the expectations. Of course, there's no good way to say that's fully reliable, so we always monitor that. But yeah, usually if these points are in there, then this thing is working. And otherwise, we have other tests, of course, and that cover that more end to end and ensure, therefore, that also on the screen the right thing is happening. Right, so if we would run this, just did that, was just running here a single test, then the single test in this case runs, of course, a little bit longer, because with a single test, you don't get the speed up, right? You just get now the time to scaffold this one directory. But the other tests, of course, they would now take advantage of the structure that you can see here on the left-hand side, where you already created a dist folder automatically. You also created now a folder for the test suite. And in there, there's a temporary folder now for this template that would only be created once, of course. And from this template, you just get then a copy in there, and every modification is done in here. And creating that template and everything, that took most of the time because npm installation processes take longer, right? And overall, the 40 seconds are really therefore, skewing the result. Nevertheless, all the other tests were skipped, and this test was run successfully. Of course, you could also say this test might not run if you, for instance, go to a version where you know it has a problem, and then you would see the test not pass in the same sense. Right. Of course, running locally can be just one part of the story. Most of our tests are run, as mentioned, periodically, so every day at 4 in the morning. What we are doing here is metrics testing. So that's the other thing that is more efficient than running it locally, because here I just ran it in one configuration. But actually what I want is, since it's a CLI utility used by many users, I want to run it in multiple configurations. I want to run it with different versions, in our case of Node.js. I want to run it maybe with different versions of our command line utility. And I want to also run it on different operating systems, because there might be some part in the CLI that works, I don't know, on Windows, but doesn't work on Mac. And so I want to identify that. And that's, of course, something that on a local system will be, well, difficult to do. And that's where the CI/CD shines. Right. You also get, of course, other improvements there. You get the notifications when something fails. So you got something every day that you can look for if you have an issue. And you should, of course, have look at dynamic dependencies for that. What I mean with this is, of course, you can, let's say, harden everything. You can make, for instance, that all your templating that you do will be done against fixed dependencies on, for instance, NPM. So that you always depend on, I don't know, we've seen emoji lists, let's say 1, 2, 3 should be the version. And that, of course, is up to some degree advisable. But doing all the dependencies in a fixed way is certainly not advisable, because if all the tests are always green, they will always stay green. But your real users, they will not make all their dependencies, of course, fixed. So they will usually say, oh, I just don't care. If, let's say, there was a patch version change here, I want to take it because, I don't know, it might contain a hotfix for security vulnerability. And so you should follow that because your end users will too, right? And so a change in, for instance, your utility might, of course, be good to trigger your tests. But overall, even if your utility didn't change, you should still run the tests and then with updated dependencies, just to emulate what real users would do. So always have the trade-off in mind between having everything reliable and reproducible in your tests and having that as real world as possible. And somewhere in the middle is where you want to be. That's what you should consider. Now, matrix testing in, for instance, Azure DevOps works like this. In other CI/CD pipelines, for instance, GitHub Actions, it works very similarly. It's also a YAML file, but of course, some names are different. What you're doing there is usually you define a certain key called strategy, and in there you can have a matrix. Then you enter a list of good names. So you, for instance, assign Linux Node 12 for where you want to run on Linux with Node version 12. And then inside, you can actually have any kind of variable that you like. So these names are all made up, image name and node version. What you actually do is that you then use these variable names when you, for instance, assign a certain image or when you install a certain version of Node. And then you can refer back to the variables that you assigned. And what Azure DevOps will actually do is it will then run all these things in parallel. At least up to the, let's say, purchase parallelism level of Azure DevOps. So if you just have one because you have on the free tier, then you will still run them sequentially, but you will just run all of these that you can see here in one run, right? So here you can see we got now the Linux jobs running the different versions of Node. We got the Windows job, but all running in parallel. Windows took a lot longer. There you can see the Windows is just, well, I think having not such a good performance on the NPM install. That was the reason here, but our test itself, same time. Right, what you can get back is you can make nice batches. So each of your, let's say, matrix sub-pipeline also can have a dedicated batch. So you can have a batch for the whole thing that you see on top here, but you can also have a batch for each pipeline. And that gives you, for instance, already a good indicator level that you can, for instance, use on some internal dashboard or here on some page. So now when you get partially succeeded or even red ones, then it's time to investigate. In our case, we get partially succeeded because I think it's now possible, but back then when we started those, it was not possible to just say some subtask failed, in this case, running the tests, but then we had a successful ending where we just published the test results, so that will always be successful. So Azure Pipelines just evaluated that to partially succeeded. in our case, therefore, yellow means usually red. And so you need to investigate. But again, since you're using jest, have JUnit as output, that is then quite easily doable. Plus, of course, we publish, as mentioned, all the generated files. So you can even then look back and say, hey, how was that? It was this one test that was failing. Let's have a look at the published directory and let's investigate that. With that being said, have a look at the repository. It's called PyroCLI Integration Tests. And I wish you a great conference. Get in touch, connect to me on LinkedIn or Twitter, and let's exchange ideas. Have a great day, everyone. Bye.
Wow, that was an amazing talk. Florian, would you like to join me on stage?
Yeah, I'd be delighted to.
How are you doing?
Great, thanks.
So in the beginning, before your talk, you asked the audience to answer a poll question, and we have the results of it. So what do you think about it?
I would say, yeah, as the expectation goes, right? I mean, great.
I found it funny that someone answered that CLI stands for camel, lion, and iguana, though.
I mean, what can you do? It is all context dependent. So maybe
Exactly.
that's a good choice. I don't know the background here for the answer.
Yeah. So
what I find more interesting is that it doesn't add up to 100, but rounding, right? Oh, okay. Someone just changed it. Now it adds up to 100.
Yeah. So we have a few questions from the audience that I would like you to answer. So the first one would be, which is one that I'm pretty curious about as well. Have you already used Cypress site.exec command to test CLI utilities? Because in your talk, you mentioned about using Playwright. So have you already used the site.exec command for that?
No, I have not. So the Playwright part in my talk was only used for a fraction, right? So all the tests were still run from Jest, but here we used not the Playwright as a test automation framework, but rather as a browser automation framework because we wanted to use the browser, get some information from there. But Cypress might be also a viable option there. And I use Cypress in a lot of projects for then browser-based end-to-end testing. So that might be also a great option.
That makes a lot of sense. Another question also from the audience is if you have any thoughts on testing APIs using curl, since it runs in the command line.
Good question. I mean, usually, depends on where you start from, right? So if you start from what we had already a Node.js-based project, and you, of course, want to maybe leverage the Node.js ecosystem, then I would say don't use curl, but already start your request in Node.js, and you end up with something that you can manipulate and, of course, investigate from that framework. But of course, if you, let's say, start from a completely different angle, then it could make sense. But of course, the thing that I'm missing is what would you then use, for instance, for inspection of the result? Would you use a tool like JQ, for instance? How do you make the assertions that they are reliable? You may still need, of course,
you would probably mix it with something else, right?
Yes, and that is, of course, the basis. I don't know. I mean, every tool can be a good tool if used in the right context. For us, of course, it made sense from the context, and here using curl, for instance, wouldn't have made sense.
For sure. So another question that we have here is, can the file system cache also be a remote cache? Would that be possible?
Yes, it could be leveraged like that. The basic idea is, if you would do that if you ran already a certain test, I don't know, for let's say locally you have Node.js 14 and you ran already all the tests using Node.js 14, then when you hand over your test code bases and it would be run automatically, CI/CD, then for instance, Node.js 14 would all be found in the cache. and you would get a massive speed up for that portion, right? And so if you have, let's say, a lot of developers using all different bases already for running their tests, you will get that benefit. You could do that. Yeah, we didn't do it, but you can.
Yeah. That makes a lot of sense. Another one that I find it very, very interesting here, can this kind of tests be run in parallel? I think you kind of mentioned that in the talk, right?
Yes, so we run the test suites in parallel, which is for us the biggest, let's say, speed up factor. Running the tests inside a test suite in parallel would be a little bit more tricky. I mean, they all depend on forming this template as suggested there in the talk, but could be done as well. Usually we don't do that because there are still, I mean, you would still need to have your tests already figured out in a way that they don't collide already, because sometimes, I mean, ports, etc., they're all safe, but you don't know, right? So if you we just well, we said the biggest.
I wonder how difficult is it, because in other kinds of testing, unit testing and strength testing, we always care about making the tests as much independent as possible so we can leverage parallelization, right? Is that too difficult to do when we're doing like the CLI testing?
I would say no, it can be very, very similar. It's just that we didn't do, hadn't specific eye on it.
Awesome. Florian, thanks again for the great talk. And if you want to, keep chatting with Florian, you can ask more questions and he'll be able to answer them on Discord. Thank you very much, Florian.
Thanks. Have a great evening, everyone.
And now back to you, Cecilia.
Thank you so much, Valmer. All right, and also a big thank you to our silver sponsors, Stream and Yoast. Your support is very much appreciated here at TestJS Summit. So let's go ahead and meet our next speaker, Nikolai, talking about tiny tests, large results. So Nikolai is a senior solutions architect at Sauce Labs. He has an extensive background in software testing, quality assurance, and test automation as the CEO and test automation instructor at ultimateqa.com. So let's give a big round of virtual applause. And Nikolai, the stage is yours.
In today's tutorial, we're going to talk about automated atomic tests. Automated atomic tests are a wonderful way to update your UI tests and make them less brittle and drastically faster. We're going to see a few examples of those automated atomic tests, and we're going to even implement those automated atomic tests on 2 web applications. One application will have an HTML web form, and another will use a JSON web token for authentication. My name is Nikolai Advolatkin, Senior Solutions Architect at Sauce Labs and founder at ultimateqa.com. So what are you waiting for? Let's go and check out how to implement automated atomic tests. An automated atomic test is a test that tests only a single feature or a component. They typically have very few UI interactions and typically touch a maximum of 2 screens, especially with front-end UI automation. The reason why I say they typically touch a maximum of 2 screens is because these automated atomic tests will typically have setup state where they need to set up the state of an application, and then a post-setup state where they need to perform a validation. Automated atomic tests have several good environments in that they are much faster and much more stable than your typical automated tests due to the fact that they decrease the amount of latency that we have to deal with, and they decrease the amount of UI interactions that we have to perform. Now, I got a question for you. This test over here, if you look at it and analyze it, do you believe this test is atomic? At first glance, this test might actually look atomic, right? In that it's signing in, validating that we were able to sign in, and then it adds an item to a cart and asserts that an item was added to a cart. It's close to being atomic. However, it's not actually atomic. The reason why it's not is because it has to log in and validate that we have successfully logged in. There is no reason why we can't test the UI login in a separate test and ensure that works. And then afterwards, what this test really cares about, what it actually wants to test, is this portion right here. And so we can save time and stability by performing these interactions without using the user interface. Atomic tests can come in many forms. Some of them can be extremely simple. For example, when we used to write automated atomic tests that click links, we actually have a wasted action and a wasted validation in that we need to click a link and assert that the link goes to the right location. What we're actually interested in is the href attribute of the link, which we could easily validate in this manner, making our test faster and less brittle. So let's go ahead and take a look at our first web application, which is going to have an HTML web form, and we're going to be able to log into this HTML web form, but instead of using the UI, which is not efficient and not atomic, we're going to be able to make a web request that's going to end dropping a cookie in our browser, and then we're going to be able to bypass the login without interacting with the UI. If we come to this application, there are many tests that are here, but I'm going to focus on one at a time just to give you a better understanding. The very easiest test to understand, which is the positive test case, is going to be this test case here called redirects to dashboard on success, right? This is the very positive test case where we visit the login page. And by the way, you can see our application on the right-hand side. If you're not familiar with Cypress, it displays the test execution on the left with the actual application on the right. And if you did want to explore the application in another browser, you definitely can. Here it is, and it performs all the same exact operations. But with Cypress, for example, it's very easy in that you can see what the test is doing and then see the actual application on the right-hand side and even interact with it if you wanted. You can see that the very first step that this test does is it visits the / login of our application that is on localhost 7077. And after that, it performs the standard operations that you would expect in order to actually be able to log into the application, right? So it's going to get the username and type in Jane Lane. It's going to get the password field and type in password. And then it's going to submit the form. Once the form is submitted, you can see we do a couple of assertions. First, that the dashboard page is there, right? So our URL includes dashboard / dashboard. So that means that we were able to successfully log in. Second, we get the header and assert that it contains Jane Lane. So almost checking not only that we're logged in, but that contains the right user. And we get the cookie that corresponds to our login and make sure that there is a cookie that exists. So take a look at the application tab here and in our cookies. Currently, there is nothing available here. I've cleared it. But if we rerun the test, and of course, as I mentioned, it does interact with the application and actually logs in, you can see that now there's a Cypress session cookie that's dropped, hence why we are able to log in through the application. The challenge with this test is that, again, it's not atomic, right? In that it does interact with this login form, and then it logs in, and then it validates that we're logged in. So that's great. But if you wanted to do any kind of actions beyond this, for the login, we'd be doing the same thing over and over every single time. And so it's repetitive and unnecessary, and we can make that action more atomic. But let me actually show you the rest of the tests so that you better get an understanding of what the application can do. So I uncommented the only part of the test, and so now we have all of the tests that are available here. And these tests, of course, as good end-to-end tests or any kind of test should do, they kind of help us to understand the functionality of the application without actually manually stepping through it. So the very first test here is called unauthorized, right? And so where the expectation here is that you're redirected on the visit to /dashboard, right? So if you're not logged in, you should be redirected. And so this is what this test does. It tries to visit dashboard, but then it gets redirected to you're not logged in and cannot access this page. Hence there's an assertion that gets the H3 and checks for that message. And it checks that the URL includes unauthorized in it, right? So if you're not logged in, can't access the dashboard page. If we try to log in by doing a get on the dashboard page, we will also be unable to do that. And so we're expecting a 302 to come back to us as a result when we try to log in without a cookie. And we'll also expect the response to come back with unauthorized in the body. If you try to interact with the actual form and you try to log into it with, for example, invalid user and the valid password, we expect there an error to be visible and the error to say that username and or password is incorrect. And on success, you've already seen this. If we visit the dashboard, type in the valid user and the valid password, we get a success in that you're able to visit the dashboard. By itself, this test is atomic and great and very useful to test a single time. Once you're able to log in with the web form through the UI, you know that it's going to work and it no longer needs to repeat it in the rest of the tests. And so how do we make it atomic? So in this case, for this web application with an HTML web form, the way that it works is you submit a request. How would an atomic login actually look under the hood? Well, as you can see from the documentation of this test here, we can simply perform a web request that will allow us to log in. The web request is simply going to be a post to the login URL, passing in the valid username and password, and then that will automatically set the session cookie. And so now after this point, we can perform any operations that we want that are behind the private application interface. So let me show you what exactly that looks like. And so here you can see doing the post to the login, right? And then showing you that the cookie does exist. And in fact, we can even simply just take a look at this test so that it's focused. Go back here to the application, get rid of this. And then if we rerun it, we're going to be able to see that there is a cookie. And nothing happened in our application, right? But if, for example, now we come and try to access the dashboard because we are logged in and we have a cookie in our browser, we're able to access it without actually logging in. This time, instead of our application being an HTML web form, it's actually going to use JSON Web Tokens. JSON Web Tokens are a very common industry standard method of basically authenticating into applications and allowing access to certain parts of the application based on this web token. If you want to learn more about it, you can go to this website here, jwt.io. But basically the way it works is you submit a request with your username and access key or username and password. And then based on that, the application will verify whether those exist in the database. You get back a token that looks like this. And now this token is what you can use for authentication. Very common in many applications in today's day and age. So extremely useful to be able to do this in our automated test. Here is the repo that we're going to be working out of. As before, it's very similar. This folder that I'm in is part of a much larger folder. I can show you exactly here. So you can see the folder I'm in is logging in JWT. If I navigate up, you can see I'm in the larger Cypress examples repo. And then, as I said, we're working out of logging in JSON Web Token folder. The application we're going to be working on is a Vue application, and you see the instructions on how to start the app here, which I did over here. Actually, I simply ran npm run start to start the application, and so that's running in here. And then in another terminal window, I ran npm run Cypress open, and that opened up my Cypress browser. And so now let's go take a look at the tests to see exactly what they're doing and how to do it through the UI, and then how to do it without a UI through an atomic manner. The way this app is going to work is it's going to send the login credentials, and then those login credentials are going to be stored in local storage in an item named user. You can see from this screenshot here, there's our token, and then any requests that we make afterwards that are behind this authorized information, that's going to require the authorization header with a bearer token in order to be able to access the resources. And so if we, for example, take a look at the network tab here under the users, you'll see that there's an authorization and a bearer token with the JSON Web Token, and that's how users can get access to different parts of the application. Once Cypress is up and running, we'll be able to see these two specs here, right? One is using UI, and then the other one is not. And so if we pull up this using UI spec, you'll see all of the tests that are performed, right? Using UI, it'll be something very standard you've seen before, which is basically getting the username, typing in that username, typing in the password into the password field, and then clicking the login button. And you can see what happens before and after. Afterwards, we are basically checking here. You can see there's a web request happening of a post 200, and then we're doing a number of operations, such as we're making sure that we are at the correct URL, expecting this header to be visible, and then we're even expecting that there is an item with a username first name to last name, and then it has this token that is a JSON Web Token, and we're expecting it to be a string. And then there's a bunch more assertions on different parts of the web request. There's even more assertions like this, checking that there's a logout link, and then clicking the logout link and logging out and asserting that we're on the login page. So if you try to access the localhost 4000/users, this URL, you will get unauthorized, right? So you get this error message. So if we come here and try to access this application, invalid token because we can't get there. And so we're supposed to get back a 401, right? So if we come here, inspect, and come here to the network, and then we do XHR and do users, we will get here a 401. You can see the user's document returned was 401 because you're unauthorized. And so this basically obviously shows a positive test case and a negative test case, both through the UI. Oh, and here is actually one with the UI that will try to log in with an invalid username, right? So typing in username, typing in a wrong password, and then clicking to log in. And then, of course, it's going to get that username or password is incorrect. And hence, it's doing that assertion to make sure that it exists. So that's our UI test. Wonderful, again, fast on localhost. Will be much more cumbersome when we actually deploy this to an environment and have to travel over the network to interact with this, and more flaky as well as a result. Hence, we can bypass all this using web requests as we did with the previous web application. So if we wanted to make the same test atomic, we have these specs here, and I'm going to run them. Unfortunately, they're not as useful to see through the Cypress UI because they do make a bunch of web requests, and so the information behind them is not super useful. But you can see how we can make an authenticated request, make sure that we're logged in, and show loaded user. So instead, we can actually look at the code to understand how to make this possible with JWT. So if we look at this spec.sci.js, we can see that the very first step that we do is actually hit an endpoint to authenticate a user with a username and password, and then store the returning body inside of the user. Then, in order to be able to add the item to our local storage, we need to set that item called user, and we stringify that user, hence enabling that bearer token. And so once that's set, we can try to hit this endpoint with this bearer token, and we are able to access this user, without which right now we would not be able to access it, but with it we are. And then, of course, as a result, we can check for different kinds of conditions to be or not to be visible. And that's it. That's how you create an automated atomic test using a JSON Web Token login mechanism. Now, there are actually lots of different types of login mechanisms, and certain ones may be relevant to your application, others may not. There are many more examples here. As you'll see in this repo, you'll see all of these login examples right here, from basic auth all the way to single sign-on. So depending on your application, you're going to use the relevant login mechanism. And also, as a bonus, I've linked a bunch of bonus resources to how to do automated atomic testing in the README. It's at the bottom of the README. So definitely be sure to check that out. Thank you so much for joining me in today's tutorial about automated atomic tests. And if you want to learn more about me or catch up with me, you can find me at ultimateqa.com or my YouTube channel or any of these other social medias down below. Thanks again so much for your time, and I'll see you next time. Take care.
Thank you so much, Nikolai, for that amazing talk. I love seeing those examples. And so, as a reminder, we want to see Twitter full of all of your tweets with the hashtag TestJS Summit. Show us what talks that you're watching, any comments that you have. Tweet it with hashtag TestJS Summit, and we'll be looking out for your tweets for that raffle of multi-passes to Get Nation and t-shirts. You can join the discussion room straight after our next break. We'll be discussing the future of testing. That's at 6:30 Central European Time. You can join the discussion room in spatial chat. All right, so now it's time to grab some tea or coffee, maybe a quick snack, and then we'll be coming back. We will continue after a short break with some more really great talks and programming. So make sure that you stay tuned.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Hello everyone, welcome back to TestJS Summit production track. I hope you got the time to grab some nice coffee, tea, water, juice, whatever drink you prefer or snacks, because you need all the energy you can to catch this next talk, which is by a very, very amazing speaker, Debbie. So Debbie is a senior program manager at Microsoft, and she's also a Google developer expert and GitHub star. She has over 10 years of experience in front-end development. And apart from being so enthusiastic in tech and sharing all her knowledge with us, she also shares all the love with swimming and all kinds of sports and keeps us motivating about other stuff apart from tech. So I really like that. And yeah, she is one of my favorite, of course, you can get it. But yeah, she will be talking to us today about testing web applications with Playwrights. But before we move to the talk, Debbie has a question for you also. Pull out your Slido now, and 0304 is the code, and give us the answer. Debbie is wondering, the Playwright API can be used with all the following languages except. So the options are TypeScript, C++, Python, .NET. So go ahead, answer the poll, which is the one which Playwright cannot be used with right now. And we will discuss with Debbie after her talk. Also, do not forget to ask the questions in the production Q&A-production-track channel. And we will discuss those questions also with Debbie just in a while. And with that, let's give a huge round of virtual applause and welcome Debbie to stage. Debbie, take it away.
Testing web applications with Playwright. It's time to play your test right. Hi everyone, my name is Debbie O'Brien. I'm a senior program manager at Microsoft, and I'm basically working on advocating for Playwright. I'm an international speaker, teacher, YouTuber, open source contributor, and you can follow me on Twitter at Debs_O'Brien to see me running and cycling and doing all sorts of sports across the island of Mallorca in Spain. So we're here to talk about testing, so let's get straight to it. Playwright testing, reliable end-to-end testing for modern web apps. Works on any browser, doesn't matter what platform you're on, any browser, any platform, one API. Tests run in full isolation. That means one test is here with a browser context, another test is here. They don't leak things through each other, right? So everything here is in full isolation from the other test here. Fast execution. We got powerful tooling, which I'm going to talk about a lot in this talk, and multi-language, which means you can run your tests in C#, in Java, in Python, or in JavaScript and TypeScript. I'm going to show you TypeScript today, but you can choose any of the other languages that you want. So I'm going to show you the VS Code extension because I absolutely love the integration with VS Code. It's very, very cool. But don't worry, you can still use Visual Studio. You can still just use the terminal or whatever you prefer. But let me show you the extension. So look for the Playwright test for VS Code by Microsoft extension. And then basically in your command panel, just write install Playwright. And click on that, and what you get is now you get to select the browsers, and you can choose Chromium, Firefox, or WebKit. You can choose all of them or just one of them, and later you can configure it. So don't worry too much if you're not sure which you want. There's another option there. Use JavaScript. If you don't want to use TypeScript, it's TypeScript by default, but you can use JavaScript if you prefer. And then also the GitHub Actions. By clicking that box, we're going to get a GitHub Actions, and it's going to basically work out of the box without you having to configure anything. You'll be able to run your tests on GitHub, on CI, in every push and pull request. So once you've installed, you're going to get this. You'll get that GitHub folder there with the actions inside it. And you get a test folder with an example.spec TS file. That will have a very small test in there, which we're going to go through today. And then there's a test example file, which has a to-do demo app. And you can have a look at that in more detail. And then the Playwright config, in case you wanted to later add or remove some of those browsers or put testing for mobile Safari or set up a dev server to run your application on localhost 3000 before you run your tests, etc. You can do all that in the config, but you very rarely need to touch the config because everything just works. So when you want to run tests, you can run all tests. You can run a set of tests, a single test, and tests run in parallel without you having to do anything. Automatically runs in parallel, which makes them super fast. So I'm going to run the test using the VS Code extension. Again, you could use the terminal and just put npx playwright test. But here on line 3, you'll see this lovely green triangle. So I'm going to click on that, and then basically it's going to go down through each line and it's going to run the test. Now you can see it opened up a browser window there for me, and I was able to see everything that's going on. I'll just play that again. You can see super fast, right? That's because I have this show browser ticked, and you can uncheck that if you want to, if you do not want to see the browser. If you want to see the browser, make sure that that is checked. So with live debugging, if you have any errors in your tests, I mean, you never have errors, right? But if you do have any bugs or anything, you have live debugging and error messaging in VS Code itself. So again, we have our test here in VS Code, and I'm just going to break this here, right? So get by text star, I'm going to run that test, it's going to break, and it says error, strict mode violation. So Playwright's saying, hey, look, there's 1, 2, 3 elements there, and you can have the whole log. Now, if you don't want to read the log or don't understand the log, you could basically just set a breakpoint and you could run that test again. So you can kind of see it. So running it in debug mode, and we can now go through that and see what's happening. So at this point in time, Playwright's saying, hey, look, get by text star, resolve to 3 elements. Here's one of them. Here's the other one. And down the bottom, we've got another one that has the word star inside that getting started text. So Playwright doesn't know which one you wanted to choose. So it's saying, hey, this is breaking the strict violation. So you can play around and live debug this and say, okay, what if I put get star? Get star only resolves to 1, so that would be okay. That would work. Again, we can kind of go back into here and play around and put something like, imagine we put Playwright, right? We put Playwright. There's way too many, okay? So it's kind of say, hey, there's 12 of these. This is going to be really, really difficult selector to choose from. So yeah, so basically going through this, you're able to kind of live see what's going on the page, what Playwright's trying to select and see, and you'll be able to then, make sure that those selectors are much better and much more precise. And then you can just continue, add more debugging, more breakpoints, or just step through that test, stop it, play it, restart it again and again, etc. Now, locators, what are locators? So locators are a way to find elements in the page at any moment with built-in auto-weighting and retryability. Yes, built-in auto-weighting. That means you don't have to do anything. Playwright's going to wait automatically for that locator to be ready. You don't have to set timeouts or do anything like that. So locators look like this. They're strict by default. So it's page.locator, data test ID equals directions.click, for example. That's if you're using IDs. Now, even better than that, let me show you something else, because Playwright now has new APIs inspired by testing library. As you can see by this tweet from someone in the community, a lot of excitement there. So we've got like, get by text, get by role, get by label, get by placeholder, get by alt text, and get by title. And just to show you that in kind of more detail, you can see here. So await page, get by label, username Phil John. Await page, get by label, password Phil, secret password. Await page, get by role button, name sign in. And then expect the page, get by text, welcome John, to be visible. So those, make sure you're using our new locators, get by label, get by role, get by text, etc. And in case you're kind of wondering, like, oh my gosh, this is like so difficult. How am I going to, know which selectors to pick? How am I going to know which ones? We have a pick selector option in VS Code. Now, if you're not using VS Code, you can also use the terminal. You can basically launch the inspector and you'll be able to do the same thing. So let me show you. So here we have our page, and as we hover over it after clicking that pick selector, we now get by role heading, and we can click that heading there. And inside now our pick selector box, we've get by role heading name installation. And now I can just press enter. It's going to go into my clipboard, and I can now go into my code and basically just paste that into my code. And now I've got my new selector set up, and I'm able to kind of just use that. So I can go along here again, and I can hover over and see get by role link. This is name equals how to install Playwright. Let's check over here, get by role link. This is lovely, get by role button. And this is name, switch between dark and light mode. So that's the name of that one. And again, hovering over each item is going to give us the selector that we want. So it's a nice, easy way of kind of seeing what selectors are available to you and easily able to just copy that and put that into your code and use it. So yes, pick selector box there. Make sure you play around with that and have a lot of fun picking your selectors. So make sure you're using web first assertions. We have a lot of assertions. We got to be checked, to be disabled, to be editable, to be empty, to be enabled, to be focused, to be hidden, to be visible, to contain text, to have attribute, to have class, to have count, to have CSS, to have ID, to have JS property, to have text, to have title, to have URL, and so many more, right? So I should be a rapper, right? Yeah, so they're all your assertions. So that's what's going to give you that auto weighting. So make sure you're using those assertions to make sure you get that. Now, let me introduce you to CodeGen. CodeGen is my friend. I love CodeGen. CodeGen is amazing. CodeGen will generate tests by recording your actions. Now, it's not perfect, but it's an amazing way to get started and to really help you kind of ease into testing. If you're new to testing especially, this is a really good way to get started. So let me show you what CodeGen does. Now, again, I'm going to use the VS Code extension, but you could totally just use the terminal and launch up that inspector and be able to use it from there. So from VS Code, I'm going to go into that testing sidebar. I'm going to click record new. And what it's doing is it gives me a browser window, but at the same time, it gives me a test1 spec.ts file. It's importing tests from Playwright Test, and it's starting off that test block. Now I can go to any URL, and I'm just going to test the Netflix website for now. And I come along here, and it's got a wait page, go to Netflix. This is great. Now I'll click on this button accept, and you've got this lovely get by role button name accept.click. So fantastic. And I can continue to carry on and do things. So I'm kind of clicking on this logo here because I want to make sure that logo is there. The user might not click on that logo, right? But I'm just clicking on it so it records that action, and I'll later change that to an assertion. Again, click on that heading, and that's not normally a click event, but I want to click on that so that it's there, and then I'll turn that into an assertion later. Now let's do something fun. Let's go down to the Help Center. We open up a new page here, and let's click on something. Let's say can't sign into Netflix. Okay, this looks great. We'll click on that title. That make sure that is there. Lovely, that's perfect. And was this article helpful? Let's click yes. And we'll just check the thanks for your feedback. Did that text exist? That's great. Again, we'll change that assertion. And let's start the live chat. Now we've clicked on the live chat, and what do we want to do? We don't want any of those. So let's tell us what your issue is. Let's click on that. And great, we're now chatting with the Netflix Help Center. Hello, what can we help you with today? Lovely. Let's just send a reply in there. Let's say testing your chat, and let's send that in. So now I'm in an iframe, I'm testing the iframe on the website. I want to chat with an agent. Lovely. Can we sign in? No, let's not sign in. Someone will be with you shortly. Great. And the wait time now is 1 minute. So we can check that that is there. And let's see what happens. So we are now interacting with an iframe. We're able to easily test that iframe, as you can see, and make sure that the chat works as one would expect it to work. So I'm now chatting with Marcial. So thank you, Marcial, for replying there to me. And I'm just going to say, hey, I'm just testing the chat. Thanks, Marcio. And we'll send that in there. And then let's not bother the people at Netflix any longer. So let's end that chat. We'll press end, click that button. Yeah, we want to end it. And email me a transcript of this chat. That sounds really cool, actually. Let's do that. So we'll click on that and we put in our email. I'm just going to put Debbie and press send because I don't want to put my email really. And we've sent this transcript to the chat, to the email. So that probably shouldn't have. So we can go and fix that code, right, based on how we're finding things. As you can see, I'm clicking around and I'm even finding bugs as I'm clicking around and writing the test, and I'm not even actually writing any code. So cool. Back in the footer, we can open up another domain. I'm now testing another domain. I'm testing this fast.com from the Netflix footer. Check that that image is there. Let's click on that button, that show more info button, and make sure that the client is there. So again, I'm able to check over multiple domains. I'm able to check iframes, and all my code is written for me, as you can see. And I didn't even have to open any code, right? Now, obviously, we're going to have to change some of this, which we'll go through in a second. But you can see there's my iframe being tested. You can see my other pages being tested, and everything here is written for me, bang, right there in VS Code. And I can just go along and make sure that works by literally clicking that button. That's going to basically run up the browser. It's going to go through here, and you can see it started up the chat, and we'll go to that 1 minute wait, and look, Playwright is going to wait for that to be available. Bang, it's done, it's there. I've got Shania this time. Everything works. Going to the next domain, testing that works, and up comes my little button. It's going to wait for that button. It's waiting, it's not there yet. Once that comes up, bang, I've got there, and everything is as expected. So no timeouts had to be set there. We have everything working. So again, we should be using web assertions, and you saw I clicked some of those headings. So then I went back over this test and I improved it. So I changed some of them, like the logo, to be an assertion, so I expect it to be visible. And I was able to look at these page get by role heading. If it's a get by role heading, and I want to make sure that that is visible. Get by role link, yes, that's a click event, that's perfect. Again, the next one is the URL, that's good. Get by page link, click, perfect. And we can go down through the test, and every time we see a get by role heading, that one we just want it to be an assertion, so we can easily then modify each one, which makes it a lot easier to write your test, right? You could totally write this completely all on your own without using CodeGen if that's what you're into, but I just find using CodeGen a lot easier for getting started. So let's talk about show reports. So when you've got your tests, this is at the moment now, I need to use the terminal for this. I can't use the VS Code extension. So I want to run my test first, npx playwright test, and then I want to show report, npx playwright show report. Now what this gives me is a whole report of my test, and I can see, whoa, it failed on Firefox, it passed on Chromium and WebKit, and then I could go in and inspect what happened in Firefox. I can see a whole log of it. But I want to show you the trace because the trace is so much more fun. So that little icon there, the three little bars, so I can click on that and it will open up the trace, or I can go into detail of that and you'll see at the very, very bottom the trace as well. When I click on the trace, what it will open up and show, well, first of all, let me show you how you can run the traces, right? You can record a trace for each test locally using npx playwright test -- trace on. Now, normally the trace is run on CI on the first retry. So if your test fails on the first retry, a trace is recorded for you. You don't have to do anything to set that up, it's all done. But if you wanted to do it locally, you would do npx playwright test -- trace on, and then basically open up the report and then click on that and you'll see the trace. So this is the trace here. Basically what the trace is doing is it's recording every single thing that happened during that test. So you'll be able to then go along that timeline and in your own time, go back and forth and kind of really see what's going on. So these are image snapshots of every single action. You can see each one is highlighted with different colors. Locator, click, frame, that was the iframe. So every kind of event is highlighted there, and you can basically go through that, scroll across, go back, kind of gently see what was happening. You can see there my email address, Debbie. You can see I sent it. You can see there's no address added in there. And you'll be easily able to point out when something went wrong, and so that someone is going to be able to fix it. They can really see, oh, look what happened there. Oh, I can see. I can really kind of slow it down and speed it up and kind of find out. Now, if you don't want to use the timeline, you can also go through the actions and stuff. Now, the actions, what it's going to do when I click here in the middle, this is a DOM snapshot, not an image snapshot. So this is even better. And you can see the click event, the action, the little red dot is highlighted there on every single action. And we'd be able to see like what happened before, what happened after. We can go through those actions and you can see which one was clicked. The text, thanks for the iframe, when I went the iframe, what's going on in that iframe, and every single one, the locator clicked there, they expect it to be visible, the iframe. And then over on the other side, you can see the call, the console, the network, and the source. So you can see at each time during each action, what's going on in that call, the duration, the wait time, which selectors, if it's strict, what value, the whole log, waiting for the iframe, the selector result to visible, waiting for the element to be visible, element is visible, enabled, and editable. And you saw I actually wrote in there because it is an actual DOM snapshot rather than an image snapshot. So that means you can also open the Chrome DevTools. You can expect the CSS in there. You can really kind of understand what's going on. And you can see then you've got like the different network requests are highlighted there. So one of them, we had one network request there. And as you go along, you can see everything that's going on as well in the source code as well. So you can see the source for your test. Now this is a PWA, which basically you can then send to someone else. So they can then see the source code rather than actually just, having to open up the actual code itself. So the metadata is also there. You see if it's mobile, etc. So this is a really, really good way of debugging your tests. I love it also when I'm building. But yeah, it's very, very cool. So make sure you check out the trace viewer. Now you can also run your tests on CI very easily with GitHub Actions. This is what you're going to get. That's already included for you once you tick that box, which is the GitHub Actions. And once that's happened, your tests are either going to fail or they're going to pass. You're going to have it red, you're going to have it green. And if they're red, especially, you want to kind of like find out what's going on. So you can run, look into those actions, go along, check out the log, and you can also see that Playwright report there. I showed you the report locally. That's where you get the report on CI, which you can then download and use Playwright to then serve that up, and you'll be able to click on that and trace and kind of, visualize that trace and see what happened in CI, why did that fail, and, debug that and improve your tests. So with Playwright testing, you have the VS Code extension. You got CodeGen, my friend, who's going to auto-generate the tests for you. You can run your tests in debug mode. You've got locators and frame locators. So you can test iframes. You can see reports. You can open up the trace viewer and really see a full trace of those. You can still do screenshots and videos if you like, but I just love the trace viewer. So that's by default. But if you prefer videos, totally up to you. You can also do that. Auto wait built in for all actions, so there's no need to set timeouts. Tests run in parallel for free without you having to do anything, which makes it super fast. It runs across all browsers and devices, so emulates mobile devices as well. Intercepts requests, follows all redirects, and bypasses cores and manages cookies for you. So who's using Playwright? Absolutely everybody. I mean, check out that chart. Playwright is open source and free. It's by Microsoft, and we absolutely love GitHub stars, so make sure you give us a star. And these are our amazing ambassadors. Check them out. They're on our community tab, ambassador page, and they're creating amazing content on Playwright. So do connect with them and check out their video and courses and blog posts and etc. And make sure you're following them. But seriously, I just have one question for you. Are you ready? Are you ready for the question? Are you ready to Playwright? I want to hope to see you all basically in the Playwright community creating great tests. Let's improve the testing scene in general. Let's write better code. Let's test that code. And let's just have some fun and make testing easy and fun. That's the goal. Thank you very much for your time. Check out our docs, check out our Twitter, check out our YouTube and our community Slack channel. And if you want to reach out for anything, you can find me, Debs_Brian on Twitter, my website, debbie.codes. And I really look forward to seeing so many more of you in the Playwright community. Thanks, everyone. Bye.
Man, that was such a power-packed talk by Debbie. So before the talk, we asked a question, and now I would like to invite Debbie on the stage with me, and we will discuss the Q&A and the poll questions. Debbie, please join me. Hi.
Woohoo! Hi.
Thank you, Debbie. That's such an amazing talk, and actually I learned a lot. So I saw Playwright for the first time, and I think I'm gonna try, and so are many of the audiences, of course, after seeing the talk. So we asked the question, it's like a Playwright API can be used with all of these except, and I think 93% of the people say C++. So what do you say is the correct answer?
I think they did pretty good. It's quite tricky, right? Because it's C++, right? And not C++, right? And that's if you're not into the C++, then you might get confused. But yes, Playwright works on C#, or we can say .NET, right? Python, also TypeScript, JavaScript, and Java.
So we have pretty broad, coverage of languages in which you can write Playwright tests.
Exactly, which is kind of cool, right? Because I mean, if we work in the same company, right? And now our backend developers who are writing in Java, for example, or .NET, they can continue writing in their language, and we're going to write in TypeScript, and you're going to write in JavaScript because you're afraid of TypeScript, but that's fine. And and we'll be able to still use the same testing tool, even though we're using different languages, and we'll all understand each other's tests, but we'll all write them in the way that we understand. So it's kind of cool.
That's cool. So just a question which comes out of my mind out of this is that, can you write all the different language tests for the same project, or like?
Yeah, so you can decide to put your tests with your project. So if you're writing a Node.js project, then obviously if your tests are inside that project and you want to run it, you're better off running those in Node. But you can also run them outside of your project, or you could just set up a dev server in a GitHub Actions to kind of launch that server. So it all depends on where your server is running to be able to run those tests or not. But you can totally test outside your application, inside it, whatever works better.
Awesome. So there's a question. Mark R asks, I thought that it would be a question. What are the advantages of using Playwright over Cypress?
That's a horrible one because look, Cypress is great. I love Cypress. As you know, I used to work with Cypress. So what are the advantages over Cypress? I guess what I showed in the talk specifically, to be able to test chat applications, go across multiple domains, go into iframes without anything else. It just works. Parallel for free. And probably other things, but let's not go down that road. But yeah, test your applications.
I think that those two are pretty nice frameworks. So yeah. So we have a question from Marie. With the new API page.getByTestID, does this require the custom attribute to be data test ID, or can it automatically detect other custom attributes such as data-test or something similar?
Yeah, of course. So we just set one, and then if that works for you, perfect. But if not, you could write data my beautiful tests if you want, right? You can change that attribute to whatever you want, so you can configure that.
Awesome. Yeah, thank you. That sounds a pretty nice idea for an attribute name for sure. Yeah. There's also a question for people who might want to get started with Playwright. How can they get started with Playwright?
So I recommend you take 3 minutes out of your day. That's all it's going to take. 3 minutes out of your day, and literally just go through the getting started guide. I know people go, oh my God, docs, I hate docs, I don't want it. But it's so simple, because literally it just takes you through installing. You can use the VS Code extension, which I showed. And then you don't even have to write a test because you've already been given a test. Press the play button, it's going to run, right? Now you're on a minute and a half. So now another 30 seconds to get code gen, create a test just by clicking. Bang, you've got that other test, run it. And then you can put up on GitHub Actions in another minute, 3 minutes, test running up on GitHub Actions, up on CI, easy.
See, 3 minutes is all it takes, right? To go from zero to hero in Playwright, yeah.
And if you fail, Come and talk to me. If it doesn't work for you, come and talk to me. I want to know why, because it should.
Awesome. Yeah, thank you, thank you. Also we have a question. In your opinion, what is the future of Playwright?
The future is that everybody is going to love testing, and they're going to always be testing their applications. So we never have problems that we click something and it doesn't work, that the user gets frustrated. We're going to have no frustration in the web anymore, because if we make testing easy and fun, more people will test. Testing will just happen, and it will become a culture, part of the culture, like in the Netherlands, cycling a bike, right? That's a culture. Let's get the whole world cycling bikes. Let's get the whole world writing tests. So yeah, that's what I think the future is.
That is an amazing answer. Really, like make testing very common and easy, so everyone gets into it for sure. Thank you. Also, so what is, like, you have been working with Playwright for a while, right? So what is your favorite feature of Playwright so far?
You know, it's kind of hard because I'm between CodeGen and the trace viewer. CodeGen I love because I never have to think about which of those locators that you need to choose. I don't think, I just click, it tells me which ones, and then I can look at it and say, yeah, you know, that's good, looks good, perfect. It writes my test for me. That saves a lot of time. And then trace viewer, when the test fails, to be able to do that, but I'm just not really getting a lot of failed tests. So I'm going to say CodeGen because it's helping me really get a lot of tests done.
When I saw it, like for me also, it was like that. CodeGen was like, wow, that sounds super cool.
Yeah.
Sure. Yeah. So
this is why I have so much time to do sports, right? Because CodeGen's writing my tests for me.
See, now you have a secret of Debbie doing 3 hours and 6 hours of sport every day. So yeah, so like I already asked you, but just for the audience again, what's like how many hours did you do today, and what are you going to do next for the sports?
Yeah, so I ran to the gym. That was 1 kilometer. I played a match that was an hour and a half, a paddle match. Then I ran home. That was another kilometer. And in an hour's time, I'm going to run to the gym for my second match. I've got actually 2 matches, but they're shorter matches. So it'll be another hour and a half. So it'll be about 3 hours, 20 minutes.
Yeah, that's just amazing. Like the way you like of energy, like it really motivates. So on that note, other question is, how to stay motivated and so energetic? Like how could people be so energetic? Like give us some tips. Come on.
You literally have to put it in the calendar. It's in my calendar that I need to go do sport, because if not, I'm going to sit here and I'm going to code all night long and I'll forget to even have dinner. So literally I put it in. If it's in the calendar, it's going to happen. If it's not in the calendar, it doesn't happen.
Plan it. But thank you so much, Debbie, again for this wonderful talk and showing us all about Playwright and answering all the questions. It was really amazing to have you today with us.
It was lovely to see you again, and thanks for having me here, and thanks everyone for watching.
Thank you. Bye. So after this lovely talk and conversation, now let's move over. And now it's the time for the lightning talks. We have 4 amazing talks back to back. So are you all ready? So please join me in welcoming Scott, Colin, Avatar, and Daniel. Let's give them a huge round of virtual applause. So with that, let the talks begin.
Hey TestJS Summit, how are you? I'm Scott Gerlach, CSO and co-founder here at StackHawk. Thanks for taking time to check out StackHawk. I hope you're learning a ton of new things at TestJS Summit, and hopefully I can teach you one more. At StackHawk, we do application security testing, specifically dynamic application security testing. Let's talk about the benefits of DAST. DAST can help you identify and prioritize your time on what to fix because it helps identify what's discoverable and likely exploitable in your running application. If you're awash in a deluge of NPM audit tasks, and it's a good idea to go after those, but often the list is long and not everything is a straight version upgrade. But also, how do you know the code that you wrote is safe? And where should you be spending your time if the upgrade path on NPM audit isn't straightforward? This is the superpower of DAST. DAST can help you find AppSec bugs that are discoverable, likely exploitable in your running code. You might be thinking to yourself, but frameworks have basically prevented any of the AppSec problems from happening. And yes, many frameworks have done a good job of preventing issues like SQL injections and cross-site scripting, but most all of them have the unsafe version of that to help you do your complicated things and unfortunately make mistakes. But some people don't know about Dast, and those that do may have run into the problem with Dast. Let's look at an example. Back in the old days when we built server-side applications that ran the data layer and the presentation layer, everything was fine and dandy. The legacy Dast scanner could scan and test the legacy application without many problems. You get good results, identify some serious AppSec bugs, and everything was hunky-dory. But then something changed. Then we started building JavaScript front ends. And the JavaScript front end trolled the legacy Dast scanner, and I mean trolled it. For instance, hey, when does page scrolling end? It doesn't. Where are all the forms? It depends. Legacy Dast was running along and was happy, totally assuming it was getting all the info it needed to test these new applications. The results were terrible, scans took forever, false positives for days, etc. And the worst part, there was someone else in that backseat as well. Our backing APIs are in there controlling all the data, talking to the data store backends, helping to render elements on the page, and the legacy Dast scanner thinks the front end is passing all these requests to the backend. Do we end up testing the API here? No. Are we covering the API, the whole API? Probably not. Are we even making simple requests to the API? Good old JavaScript front end. It depends. It depends on the browser or browser emulator the legacy Dast tool is using and how well it's driving, what elements it can see, when it can render, if you've built support into your JavaScript application front end for specific versions of specific browsers. Now you could think of this sort of like Selenium scripts. And in Selenium scripts, you write a specific test. I want to go to this page, and then I want to click on this button, and then this should show up, right? That kind of Selenium test. Dast is like that, except for you're expecting it to find all of the possible user input paths by itself and do a good job. It's just not going to happen. It doesn't work well. So how can we get back to better testing, better results, faster, more accurate scans, uncovering these application security bugs that are built into our JavaScript apps now? The key here is driving the API directly. Using industry standards like Postman collections, Open API spec, GraphQL introspection queries, you can have direct access to the API, understand what it does and the data it's controlling, and get fast, thorough tests. Never mind if you're building an API that doesn't have a front end at all. Mind blown. There's still good things to find in testing the front end in cookie settings and DOM XSS. Protecting all the data that you could end up potentially putting at risk is a better place to start. What are some of the keys to look for in a dynamic AppSec testing tool that will help you test APIs directly? First of all, run anywhere. Should run in your CI/CD, should be able to run against production, but really importantly, should be able to run on your local host as you're developing. Should be able to provide real test data. So in the screenshots that we've got over here, we've got Faker library turned on so that Faker is providing data. We've actually typed in data for some values. Lots of different options to be able to say, hey, API, here's what real data looks like. Also use that with your security tests. Run custom tests for broken access control and insecure direct object access. These are two of the top 10 OWASP API security things, and they're hard to test for without knowledge about how the API works. As you're developing the API, you can write things like tenancy checks. Can customer A see customer B's data? Look for stuff like, can a regular user get into the admin functions? Those are some of the really hard things to test for. Now you can write that test once and keep running it over and over and over again to make sure that the API stays secure. Like I said, you should be looking for something that's built to scan modern applications, including server-side applications, single-page apps, REST APIs, GraphQL APIs, and SOAP APIs. All of this leads to faster AppSec testing, faster time to fix, and faster getting back to your regular work of building value in the application they're building. How does StackHawk work? Finding and fixing security issues is simple with StackHawk. Our focus as a company is to help developers find and, most importantly, fix security issues. The StackHawk scanner and platform are built around this simplicity model. When StackHawk findings are triaged, the platform is giving you the simplest version of the information needed to help you quickly understand what the problem is, with simple descriptions and examples of patterns to help you identify anti-pattern. Be able to recreate the issue with tools like simple curl commands to replay the attack, and then get into debug mode in your IDE and help start stepping through the code as fast as possible to help you fix those issues and get back to your regular job. All of this is CI/CD enabled. Again, you can integrate this into your CI process and, importantly, get feedback in the CI process and the scan findings. This information can be used to break a build if you choose, based on the severity of those untriaged findings. Most of the major CI players are integrated with StackHawk. Documentation is out on docs.stackhawk.com if you're interested. If your particular version of CI isn't listed, it's a good chance that StackHawk works with it as long as you can run Docker or a Java process. Here's maybe the most important part. I mentioned this before, but you can run these same AppSec tests locally that you can in CI. So you can identify a problem, fix it, and validate that you fixed it locally before you push your code back into CI/CD pipeline. Cross your fingers and hope that I got it this time. I hope you enjoyed my talk today and perhaps learned something new about StackHawk and how StackHawk can be integrated into your API development and testing workflow. If you'd like to check out StackHawk and see how you can integrate it into your development process to keep pushing the limits on software development quality, you can always start a free trial at stackhawk.com. Thanks for watching and enjoy the rest of TestJS Summit.
Hi, everyone. Thanks for coming to my talk. Today, I'm going to be talking about zero dependency testing with Node.js, which essentially means that you can start writing your unit tests, integration tests, without having to install anything from NPM. So before getting into the nature of Node's new test runner, I wanted to talk a little bit about why a test runner was desired in the first place. So almost all projects need a test runner. So, whether you're building an application or a module that you're planning to publish on NPM or whatever, if it's, if you're planning to have other people use your code, you almost certainly need tests for it. And then Node.js actually for years now has shipped with a really good assertion library. That's just, import assert. This is the assertion library that I've been using for years now. I like it. So yeah, that's one less dependency. And then most test runners overlap a lot in terms of functionality anyway. So, every test runner runs some tests. They generally have features like timeouts, reporting which tests passed and failed, skipping tests, things like that. So that, there are differences. So some test runners are more suited towards front-end development. Some do things like injecting globals into your code without your knowledge. Some execute their tests inside of different contexts. So you might have surprising results whenever you check for equality and things like that. But so there are these rough edges, but in general, a lot of test runners have a lot of overlap. And then on top of that, NPM is just really a dangerous place. There's, over the years, there have been a number of incidents, things like LeftPad, the Colors.js thing, even more recently, the Minimist package, which I think has like 50 million downloads or something like that. Nothing happened to it on NPM, but the GitHub repository went away. So like all of these third-party dependencies that you're taking on come with some risk and some cost. And so that's just, one reason why having a test runner built in, I feel is useful. And also there's just a general trend to have more of these batteries included in the runtimes. So, now Node has a built-in test runner. I'm pretty sure Bun has one. I know Dino has one. So this is becoming more and more common. And then, here's my tweet from over a year ago. I believe that Node should ship a test runner, and I feel pretty strongly about that. So some of the features in the new test runner, you can run the test runner through the CLI interface that Node ships now with the -- test flag, or you can actually just execute a standalone file containing tests. So say you have your file foo.js, you can just say node foo.js, and if you're using the test runner in there, it'll still just work. When it comes to actually writing tests themselves, we support synchronous code, promises or async await based code, and even because Node still does have a lot of callback based APIs, we support callback based tests as well. If you're coming from a test runner like tap or tape, then we do support test style tests using the test function. If you're coming from a test runner like Mocha or Jest, we have describe and it functions. So under the hood, everything uses test, describe, and it are just kind of implemented on top of test. But if you're looking for that familiar API, it is there. We support nesting tests, so you can have a test with arbitrarily nested tests inside of it. Same if you have describe, you can have suites containing more suites and more tests, and things like that. Skip and to-do tests. So, if you just want to skip over a test, there's a few different ways that you can do that. To-do is kind of, it's similar to skip in the fact that it won't cause your test suite to fail, but it will still execute the test and kind of don't care about the result. We also have only tests. So if you start the CLI runner with -- test only, then any tests that you have annotated as being only tests are the only ones that will be executed. And then you can also filter tests by the name of the test. So if you use the -- test name pattern, you can actually pass in a regular expression, and Node will only execute the tests whose names match that pattern. So if you wanted to actually write a test, what would it look like? Here's a very simple example using nothing but Node's assert module and Node's test module. Here we have two tests. One is a synchronous test that passes, and the other is an asynchronous test which fails. The asynchronous test will, even though it looks like synchronous code, it's an async function, so it returns a promise. That promise rejects whenever the assertion fails. So two things worth noting here is, you'll see here we're using node : test. The node : prefix can be used to import any node core module, but for starting with the test module and likely with all modules added to node core moving forward, you have to use the node : prefix. If you just try to use the word test here, it would actually fall back to trying to load from userland. And speaking of userland, the test runner itself is actually published on NPM. So right now, the test runner exists in Node 18 and 16. Node 14 is still supported, though. So a few people took the code from Node Core, kind of ported it to work in an NPM module, and published it. So you can just NPM install test if you're on Node 14, and you'll still have access to all this functionality. So after you execute your test, this is what the output will look like. So this output is called TAP, which stands for Test Anything Protocol. And it's not the most easy for humans to parse, but you can do interesting things like, pipe it into different reporters and things like that and have it formatted differently. But you can see here that we have OK1. That's the first test. That was the synchronous passing test. It passed in 1.87 milliseconds. And then the second test was not okay. Not okay is how TAP indicates a failure. You can see that there was a test code failure. We expected the assertion. We asserted that the value 1 would be equal to 2, and clearly it's not. So the test failed. And then at the bottom, we have a little test summary. So there were 2 tests that were executed. 1 passed, 1 failed. 0 were canceled, 0 skipped, no to-do test. And then the entire process took about 11 milliseconds. So just some of the future work for the for the test runner. We have a pull request that's open right now for a tap parser. So that will allow us to do better reporting inside of the CLI runner. The CLI, for every file that it's going to execute, it spawns a child process that generates its own tap. The way it works now is if there's a failure, then we just take all of the standard output and standard error for that file and display it. If no tests fail, then we kind of just say it passed and don't show any output. The tap parser will actually allow us to intelligently parse that output and display things a little more nicely. We also want to use the tap parser to build out reporters. So as I said earlier, tap is not the prettiest thing to look at. So we want to implement some reporters that can actually transform that into something a little easier for humans to read. And then we'd like to build in code coverage and mocking, just because these are two pretty significant features that really make a test runner feel mature, in my opinion. So the test runner is still listed as experimental, but I don't expect there to be a lot, if many at all, breaking changes in it. I have a link here to the documentation for it, and encourage everyone to go out and at least give it a try. That's everything I had. Thanks for coming. Bye.
Hey everyone, I'm Avatar. I'm a front-end engineer at Meta, and one of my passions is working on open source tools and libraries and frameworks for other developers to use, and today we're going to talk about one of them. Now, this one in particular is a combination between that passion and my other passion, which is unit tests. I love unit tests so much that I actually built a unit testing framework. I mean, not really a framework, we have enough of those, but I did build a form validations framework that takes the syntax and style of unit testing libraries like Mocha or Jest and introduce them into the world of form validation. But before we talk about the vest itself, let's first try to understand what is the problem with form validation. I mean, we've been doing forms for 20 years now. So what is the problem? And I think there are three main problems in the world of form validation. And it all begins with structure, or the lack of, really. When we write our feature and we add the forms, we don't really know where and how to put the form validation. I mean, yes, we have a change handler and it should come out from there, but inside the forms, we usually not just care about the data, we care about the feature and the user experience. And then a lot of the validation code gets intertwined with the feature code, and then we get a pile of spaghetti code, really, that's all about both form validation and user experience. And then when we come back to maintain the feature like months later and try to add in stuff or remove stuff or make changes like make fields depend on one another, we have to disassemble all the feature-specific code that we wrote and reassemble it in a way that's suitable to our current need. And one other problem is that forms and form validation is really difficult to test. Unfortunately, forms are the interaction-heavy parts of our apps. That's where people touch, scroll, type, do everything, basically click. And that's also where the money comes from. And because this is the most interaction-heavy parts of our app, this is also the most bug-prone. And unfortunately, it's really, really hard to test. I mean, everything you want to do in form validation in terms of testing has to go through all the flows. So either user event simulation, or you have to go through all the data. And it's really hard to test, especially if you have some complex validation logic that you don't want to go all the way through. And we end up not testing those, and that's a bummer. But what types of form validations are out there? I mean, Vest cannot be the first form validation library. I mean, we've all used form validation libraries, both in the client and the server. So I'll try to get a brief overview of what's there, and then we'll understand how Vest is different. And first we have like the functional matchers, like basic functions like is email, is number longer than, that basically give us a Boolean response if some value matches some criteria. And this is really simple, and this is also really useful, but it doesn't care much about structure, it doesn't help us with maintenance, and neither with testing. And this is really useful, but not a full-fledged solution for form validation. Second is that we have the schema validation libraries that take like a next step of what we just described. They take the form of the data, the shape of the data, and the shape of the data in its entirety has to conform to some criteria. And this is good mostly for the API level, but when talking about the client, not really. I mean, what do you do when the user interacts with the form, like types inside the username field? Do you validate the whole thing, the whole schema? And also, it's really hard to describe complex ideas like fields that depend on one another inside of a schema. So it's really useful, but not necessarily the way we want it to be. And third, we have like in the client, framework-specific UI, form state validation or state management libraries that are specific to a framework, and they give you components or event handlers or directives to use inside your app. And then what it does is basically takes some control away from you, but gives you all the state management on the form and all the form validation for the form, and then you're pretty much set. And it's good. But the problem is, well, it's framework specific, UI framework specific, so you cannot share logic between your client and the server easily, or between Angular or React or Vue easily, and most of us have at least some apps or some different types of our apps. And also, because they take control from you, they put their stuff inside your app, it's really hard to take that control back when you need to bypass some behavior. It's good, but not necessarily, again, the way we want it to be. And how do unit tests fit in? I mean, this is TestJS. Well, a couple of years ago, like 6 years ago, I started writing unit tests as part of my work, and I realized this. When we write a unit test, we have our unit testing suite that usually starts with a describe. It doesn't have to, but it starts with some top-level suite that describes the idea that we're testing, our feature or our app or whatever it is. Inside of it, we have a series of tests that basically describe what assertion we're making now and what is the error that we're going to show in case of failure. And then we have our assertion, for example, expect, and what we expect it to be. And what if we could use that same idea inside of the world of form validation? I mean, well, it's pretty much the same. When we write a form, we have our topmost concept of a form that we want to describe. Inside of it, we have the different fields, so a set of fields that we want to test. And then we just want to make assertion. Now, instead of asserting behavior, we want to assert data. So I played around with this specific idea, and this is what I came up with. So first we create our form validation suite that's slightly similar to a unit testing suite. You describe, optionally, the name of the form that you're validating, and also you pass in the data from the form that the user just interacted with. And inside of it, you add obviously a series of tests. So you have a test that's very similar to a unit testing test, only that it adds one extra field, which is the name of the field that you're validating. So in this example, username. And then you pass in the message that the user would see in case of a validation failure. So you do it also both for description inside of the code and also for the user to see. And then what you have is basically an assertion, and instead of using expect, that's not really good for production, I'm using enforce that I wrote that's much more suitable for form validation, both in terms of what it does and how it behaves. So you have enforce, you pass in whatever data you want to. In this case, we pass in the data from the form, and then we add our assertion, for example, is not blank. Now, obviously, form validation is not that simple, and we can add multiple validations per field. We can add as many as we want, and we can actually add more even complex validations. For example, async validations, in case, for example, usernames are already taken on a server. And just like in Jest and Mocha, passing in an async function makes the test async. And what if, well, we don't want to go to the server in case the validations are already failing for the field to begin with, like when the username is already failing because it's too short? Well, we can tell it to skip when we have errors for the username field. And what if we still don't want the user to go again and again and again for the same username, even if it's valid locally? Then, well, we can memorize it and say, well, if the username types the same username again, well, don't go to the server again. And this is just the tip of the iceberg in terms of what VEST can do. It has so many features, so many capabilities, and it answers all the problems we usually have in form validation. Now, one of the neat features is that VEST works with anything JavaScript, basically. So if you use a framework or without a framework or on the server or anywhere really, you can use VEST. And some VEST feature is its full TypeScript support. You can validate changes upon interaction. You can have multiple validations per single field. You have warning validation, for example, password strengths. That's not just failing the submission, but just telling the user, hey, there's a problem here, and it puts the validation in a different basket. We can have fields that depend on one another, like confirmation and password. We have async validations, and we have memoization. We can group tests like in a nested describe. We can compose validation rules. We can extend VEST to add more custom enforcements, and everything is structured and framework agnostic. You can install VEST really easily, npm install VEST. It brings in some dependencies that are all specific to VEST, all were written for VEST, so it doesn't bring any third-party stuff. And there is a documentation website, vestjs.dev. There's also a link to the Discord server over there. And if you want to check it out, you can try all of these. Thank you so much, and I'm really excited to see you become a part of the VEST community. Thank you.
Hello, this is a talk about overtesting, which is you can probably understand what it is from the name, but it's a simple technique you can use to improve your test suites, improve your testing proficiency. So it's a model for thinking about your testing, really. And this talk is aimed at developers, but it's also useful for QA engineers, QA teams who want to maybe discuss with their developers their testing strategies, their testing ideas. So, key question about overtesting, this might be really obvious, but how much time do you spend maintaining your test suites versus your application code? Because a lot of my clients I've worked with, their problem isn't under testing. They're not testing too few of their use cases. They're actually testing a lot. And so what they end up doing is spending most of their time, I've observed this, up to 75% of their time or more in their test code, making the code changes to their application to add new features or fix bugs, but then having to go back and fix the tests, all these broken tests everywhere. 75% is too much. I love tests. I'm writing tests left, right, and center, but I'm not wanting to spend my life in the tests. I want to be at least in a situation where I'm spending an equal amount of time in both. And, maybe even less. Maybe I can be spending less time in my test suites, but still maintaining 100% coverage, for example. So I'm not going to suggest what that number should be, but if you're kind of in this 75% territory, and you can think about whether you are personally and on your team, but you probably want to be moving down to improve your productivity. So here's a simple question. The top screenshot is showing GitHub workflow that's run on a pull request. So I'm sure a lot of you will be familiar with this setup. The red X is showing that CI has failed, so continuous integration. Like I said, I don't see teams today who don't have CI. I think most people are writing tests. The problem isn't under testing, it's over testing. So to me, this question is key. How many automated tests do you need for CI to fail? And the answer is just one. You need one test. So ideally, whatever change you could make, if there was an issue with that piece of code you've written, just one test would fail, because that's all you need to raise the flag and stop your pull request being merged. Now, this is an ideal scenario. I don't think you'd ever get to one, but if you think about the times that this does happen, how many tests are failing for you? Are you in this kind of scenario where multiple test suites are failing, hundreds of tests are failing because of simple change you made. And this is the scenario where you then start spending that 70%, 75% of time fixing your test. So over testing, very simply, you have too many tests telling you the same thing. I'm going to show a very quick example. There's plenty of examples of this. This is one I see a lot of, where people are kind of doing scenario-based testing. And what they'll do is they'll set up the test, and then they'll print out and they'll have an expectation for the entire response or payload that they've got here. So this example is just calling fetch, and I'm checking the method, credentials, headers, and the body. But what I can do is split this test out into 3 different tests. And the test on the left here is the key one. That's the body. That's probably the thing we're most interested in, and the thing in our application code that will change the most. The 2 tests on the right, these are going to change less often. So I shouldn't expect these to break. I'm not going to be changing the method or the headers often. So these should hopefully just remain as they are. They're less brittle now. The key here is using expect.object containing. So this is definitely your friend. You can make more use of this. And rather doing these huge expectations in your test, break them down into the functional units. So that's it. That's really the idea. It's about thinking about how much time are you spending in your test code. That's an observation. You just start thinking about that. How does it make you feel? Are you frustrated by this? Rather than just being involved in that moment of fixing the test, getting the build working, stop and think, well, how can you be more productive? And then figure out ways to improve it. So I don't really want to suggest too many ways for you to improve things. This book, the second edition of this, has just been released, Mastering React Test-Driven Development. This isn't just about TDD. It's about good unit testing practices that have helped me in my career. So I definitely recommend you check it out if you're interested in figuring out all the different ways of writing tests that won't take up all your time. So to conclude, observation. Think about the time and the feeling you've got with your test suites and what's serving you well. You should be happy with your test suites. They should be helping you out. And have an open mind to new ideas. Don't shut down ideas because you've read blog posts that this is a terrible thing to do. You shouldn't do that. This is how you should write tests. Don't write tests like this. Just keep an open mind to ideas, and always come back to the idea of how easy are your tests to write, how much time are you spending in them, how do you feel when you're working in them. And that's it. Thank you very much for listening. Let me know what questions and thoughts you have.
Those were some really terrific talks. Thank you again, Scott, Colin, Avatar, and Daniel, for sharing your knowledge with us. And now for further talks, I'm handing over to Cecilia.
Thank you so much, Anuradha. I wanted to remind everyone about our raffle and conference t-shirt, our raffle for conference t-shirts and multi-passes. Make sure that you are tweeting with how you're watching the stream and add hashtag TestJS Summit. We'll be keeping an eye out for your tweets and announcing the winners later on. Also, keep in mind that we will have some amazing workshops next week as part of the conference. They are available for full ticket holders. Make sure that you register so that you can participate in any of these 3 workshops that we have going on next week. All right, so I'd love to welcome our next speaker, Murat Ozkan, with a talk on CCTDD, which is Cypher Component Test-Driven Design. Murat lives to do corrective deeds, learn, teach, fix what is broken, improve, and optimize all things around at work, open source, and home life. He's a tech enthusiast in love with testing, development, DevOps, web, and cloud. I've always found Murat to be a really great thinker who asks great questions and is always thinking of creative ways to use tools and solve problems. So he does have a question for you. If you can go to sli.do over to Slido with code 0304 and answer the question here, which is the least cost versus highest value testing type for you when working on front-end applications. So there's options for unit, component, and end-to-end testing. So make sure that you go over to Slido and answer that poll question, and we will discuss the results with Murat after the talk. All right, and so we will go ahead and again, as a reminder, don't forget to ask questions on Discord. So you go in the channel Q&A production track, you can ask your questions for Murat, and we will do a Q&A after the talk to cover those. So let's go ahead and give a big round of virtual applause, and Murat, the stage is yours.
Hi, everyone. My name is Murat. I'm a staff engineer and test architect at Extent, and I believe Cypress component test-driven design can take our front-end engineer to the next level. We'll talk about a TDD example, go through a component test. We'll talk further about component testing, a second example. We'll cover end-to-end testing in the context of TDD. And finally, we'll wrap up with recommended best practices. The application on the test is Tour of Heroes from Angular. You're all familiar with it. It's rewritten in React, and the book, Cypress Component Test-Driven Design. You'll be able to find the link to the book right here, and the final app with all the source code, everything in this presentation, over here at this link. It's a React application with a JSON server, some nice tooling. We have many Cypress Component Test examples here. Each one of them has a React testing library mirror. You have UI integration tests, stub in the network. You have API end-to-end and UI end-to-end tests. Proportion of them is 1 to 5 to 15, which gives you an idea about the test architecture. Here's our first component. You can find it in chapter 3 of the book, and final code right here in this link. Start with a placeholder test. First, you want to make sure that you can render something. You imported the right file. You have the styles. This is a good baseline start. You just copy paste this to every starting component test run. So you have that being rendered. Nice. Write a failing test, because with TDD, you have fault finding tests for things that matter. So we want a link that has an attribute that goes to react.js.org. And we have our first failure. Great. One little test failing, and we try to make that work, adding a link with an href. Want to start with something with failing, want to do the minimum to get it to work, and then you want to try to make it better. Want to use component test as the design tool to aid your red-green refactor cycles. We're not seeing anything being rendered. So we think, okay, here's an idea. Let's make sure that this is visible. So we add a failing test. Now we have a red. Incremental visual enhancements mean you can use the visual feedback that's not up to your expectation as the red indicator. So I'm not seeing it. I want something in there. I'm going to go and add an icon so I see a decent render. Something being visible doesn't really help, but I want to see the right thing. The obvious but hard thing to do with TDD is write very small incremental tests at a time. You want to build the component iteratively using tests. You want to find out more about it with the tests. Like you're ad hocking, but as you're ad hocking, you go ahead and add a step. So we have an attribute, we add a test for it, and then we add that attribute check. We write another step of test, and then we add another attribute to make that work. At the end, we think, okay, maybe we need an icon right here in this component. We add that data size selector to the top tag of the component, which I recommend makes the component very easy to find when it's used as a child or when it's used in end-to-end tests. So we do that. And then under that component, we're expecting an SVG to render because that's the icon we're looking for. If you have TypeScript and ESLint, this kind of tooling can also aid your red-green refactor cycles. Here, the property 2 is missing. Navlink is from React Router DOM. So we don't really have to have a failing test for it. And so we can just add that attribute right there. In order to make the test work, on top of that, we have to wrap it with a browser router because that's how you mount your component when you're using React Router DOM. We just wrap with a browser router. You have to always remember a component test is a small-scale application. So you have to replicate your application wrappers. You're using browser router in the main app, and you'll be using browser router whenever you're mounting your component. but your application may be looking like this, and your test mount will be looking like the one on the left. No problem. You can write a custom wrapper function. You'll be able to find the link here, and you'll be writing one in the book as well. And it's just a one-time thing. If some of your components don't need to be wrapped with some of these, that's perfectly fine. Extra wrappers do not really change how the component behaves. The component just uses whatever it needs. It's the exact same thing you would do with React Testing Library. You can also write multiple different kinds of custom wrappers, right? Some of the wrappers for these components, but different wrapper for another set of components. Back to the test, we want to add a link that has 3 spans under it with some strings. So you write a failing test for it. And then we get our failure because we don't even have that nav link data size selector. So we go ahead and add that. We add some classes to make the render look nice. We add our spans. Each one of them just has a hard-coded text. And we have a nice passing test at the end. Renders the way we want it to. The question comes up, should we break down the test or not? On the left and right, it's the same exact test doing the same thing. Left side breaks it down. Right side just does one flow. What matters is the beginning state of a test. If reaching this state is common, then in my opinion, the right side, an opportunity for a test enhancement is stronger. I prefer the example on the right. So long as tests don't duplicate though, they're order independent and stateless, either side is fine. The reason unit testers may prefer the one on the left is because they want to have a smaller blast radius. This is not a problem. You have a Cypress test runner. It's very easy to find exactly where the failure happened. You just have to be careful not to do the thing on the left. So here we have 3 if blocks. They overlap with each other. So the first one's covered in the second one, and the third one covers the second one. So this is just one test. You can just write one test, mostly the third one, with the visibility check from the first test, and that's good enough. An example of what not to do and what to do. Here's the comparison to a React testing library. One-on-one is the same thing. You can translate each line. The intent is always the same. The difference is the API style. So you have async await, variable assignments on one side, and you have a chain syntax, a little more flow on the right side. But the intent, your actions, whatever you're doing is the same. Just different ways of doing it. So that was a walkthrough of a TDD example with component tests. Now we'll have a second example and some more pointers about component testing, especially about props, wrappers of components, and parent-child relationships. So this example is from chapter 5 of the book, and here's the final code. You can use hard coding initially, or you can use console log to make your test pass. Just hard coding, everything's fine there. Then you manipulate your component either with props or wrappers. So here we have a prop. Instead of a hard-coded test, we're adding that prop right here, the placeholder. And then we add it to the component. We can pass data with props. Like here we have a prop for heroes. We're passing an empty array. And then here we're passing a heroes array. On the right side, on the top, we're not passing anything, just the component by itself. But if you wanted to, we could have a wrapper there versus context API, and thereby provide a value there, the villains array. And that's how we manipulate our component. So either you use a property or wrapper. That's how you customize your component test in Cypress and React and anywhere else. When you're adding props, you add the property. Right here, we're adding the name property. And then you add the prop to the component types. You add it to the arguments of the component, and you use it in the component. Same flow, we'll be going through it. This time we're adding the value property, a test, failing with that, right? And then add the prop, the argument, and use it in the test itself, which is in the component. And we have a nice render at some point, which we'll be using for a form. The form, we wanted it to have the ability to be a read-only also. So you write a failing test for that. Go ahead and add the prop. And if we have events, we can just stop them. Here, we have an event that's 2 keystrokes. So we want the change event to be called twice. First, the failing test, and then we add the prop, the argument, and again, we use it in the component. We want to seek failures through tests And when you have green tests, you want to prefer adding more tests or refactoring versus adding additional source code. This is very important. Sometimes you have a passing test, and then we go and add so much source code. No need to do that. A little bit of a test, make it work, make it better. If you have something working, you want to prefer adding more tests. You want to have a failure first or refactoring before you go to the source code. Here's a parent-child example. So this is a child being used as the parent, two different varieties, a name and a description. Always check if you're duplicating the test effort covered elsewhere. So you want to find opportunities to cover different functionalities. On the right, we already have a check that we're typing something and then that thing is visible. We're duplicating that test over here at the parent, and that's not good. But at the parent, you can do something else. We can check that the parent renders two variants of the child. Here's another advice. With JSX and template literals, you can be pretty creative about your selectors. I like to have a data site at the top tag of the component, and if there are any variants, I just exploit JSX and template literals, and it's pretty fun. React testing library versus Cypress component test. I think for this one, the main difference was how we do the on-change event test. On the right side is scigget, the change tag right here, and then checking the call count. And on the left side, so just fn instead of a size stub, and we check that it's been called so many times. Doing the exact same thing, every step translates, slightly different style. We went through TDD example, component example, two component test examples, some best practices over there. Now let's look at TDD with end-to-end tests. So end-to-end tests are great when you finished building your components. Now it's time for routing, state management, application flows, components talking to each other, or the backend. That's time for E2E. But remember, you want to aim to test at the lowest level and then move up when you cannot test confidently. This is an example of that. I can't do anything about routing when I'm working with components, right? I need end-to-end tests. So first you look at the child. Can I do this at the child? Nope. Then you move out to the parent. If that's not enough, you have a UI integration test. You stub out the network, but your components are talking to each other. And maybe you need the backend. Maybe your component is making a backend call or something. Maybe you can use end-to-end tests then. Routing feature with TDD example. So this is an end-to-end test. We're using TDD. It's from chapter 13, and it's the final code of this test. You always want to remember what you're doing at your child component. So here we're visiting the component, we're visiting the application in an end-to-end test, and we're making sure that header bar component is displayed. So how do we modify our application so that the header bar component is displayed? We go ahead and take a look at the child, the header bar, and there we're using browser router and wrapping the header bar. So our application is going to also have to do that. So you can cheat and always look at the component tests that you already built. They'll make your life easier when you're writing your end-to-end test or when you're writing other component tests. You'll be having the selectors already there, data size selectors, and you can always refer back. It's documentation for you. What do I do with this thing? The TDD flow is exactly the same with E2E. You want to start with something failing. You want to do the minimum to get it to work. So you just minimum add the navbar component. And then if you can make it better, do refactoring. Once things are working, prefer to add more failures. You want to have a not found route, and that should display a not found component, right? First the failing test, and then we add that not found component, do the route configuration, and we're finding out more about the application through testing in this way. If we have passing tests, we want to add tests or refactor before adding more source code. We have that passing test, we add that additional check for location, we're still green. So, okay, then we can think of another failure. You want to seek these failures. Failures are great when you're doing TDD. You want to keep adding tests until there's a failure. So that's very good. Once you have that failing test, then you can add the new feature. So here we're visiting the heroes path, and we want heroes component to be displayed. That's our failure. To make things work, we just add that feature. We say, okay, at the heroes out, we should be rendering that certain component. And that's a TDD example using end-to-end tests for routing. Let's go to the recommended best practices. There are a few of these, so we'll go through each. With API end-to-end tests, don't do naive UI end-to-end testing before you have confidence that your backend works. You want to use an API test client instead of using your UI client as the test client. This way you can test earlier in your deployments. You want to be aware of the test suites of your backend, and you want to avoid duplication. You want to use modest amounts of E2E and do targeted gap filling when you have UI end-to-end tests. And you don't want to have to repeat this UI end-to-end test if you already have confidence in one area. For instance, login works. Then try not to do the same login in every test. Maybe you can go through the back door or have another way of logging in. When login doesn't work, only one test is going to fail, and you know it's not working. Not everything has to fail. Here's your API end-to-end test strategy for CRUD. So it's creation, create and delete, update, create, update, and delete. And to be able to delete, you have to create something. But look at this. Update covers every single flow. If you test update, creation and delete are already covered. So just test update. This is the backend example. You can find it in chapter 15 and the final code here in this link. We are adding a hero, the post request. We make sure that thing got added, make an assertion. Then we go ahead and edit it, we update it. And then we make sure that whatever we updated did get updated the way we wanted it to. Then we make the removal and then make sure that it's removed from the database. Good example of an API end-to-end test. And you want to have this where the backend code lives, closer there if possible. UI end-to-end on the other side is very similar to API end-to-end, but instead you can use the API commands that you already created and isolate the UI tests. For instance, if you want to test update, you can see the database with the API command that we already wrote. You can do your UI testing, and then at the end, you can delete. We'll go through the simple creation example, but you get the idea. So we'll be first doing UI create, and then we'll clean up with the API. Here's that test. We'll go through also the UI integration test. The first ones are canceling and refreshing, and they're not really using the real network. And the final one is going ahead and adding a hero, and after adding it, it's making sure that hero is on the list. And you can find the full test over here. In chapter 17, we go through this in the React query chapter, and here's the final test. In the beginning, we just navigate to that hero. We want everything to settle. We are using the real network, no stubbing here. We are at the right location. We do the UI creation. So we fill out the details, we hit the save button, and then we make our assertions that we're at the right path. The hero that we added is displaying there. And then finally, we do the API delete, like we saw before. The thing to watch out for is each one of these steps can be lots of development, right? So with API end-to-end testing, when you're doing TDD, you don't want to go even smaller because one line of end-to-end test can cover lots of source code. So this is the main idea from here. Keep end-to-end tests even smaller when you're doing TDD. What is UI integration test? So you want to always evaluate if you need your backend to gain confidence in your app's functionality. Only use real end-to-end tests when you have to have this confidence. And you shouldn't have to repeat that cost the same end-to-end test everywhere. Be aware of what your backend is already doing. And that makes your UI end-to-end concerns even less. So be careful not to duplicate. Try to gap fill. You can judge people by what they don't do, by the cost of the things that they don't delve into. This is especially true for engineers, quote by Nietzsche. Let's convert a UI end-to-end test to a UI integration test. So we have two tests here. One of them testing refresh, the other one testing cancel. Using the real network, we're just waiting for the network to settle before we go ahead and check that refresh button does the refresh or the cancel button does the cancel. You already have an end-to-end test that's adding a hero and checking that the list is getting updated. So we don't really need this get request for real. Right? It can be just stub data. So we use a JSON file. We say anytime you hit that route, instead of the real thing, use the file, and there is your data. To be able to test refresh confidently or cancel, you don't need the backend. It's a perfect use case for a UI integration test. When you have errors, you want to test your error cases. Any test that's covering the positive flow with site intercept is a good branching spot. You want to try to test at the component level. And if you cannot test something, a negative error case scenario there, you want to move off to UI integration test. So here this is our positive scenario. You hit the save button and we expect a post request is going out. There's the perfect spot to do an error test case, a non-200 case. So we start with a 400. We also add a delay and make sure that there's a spinner at first, and then we get the error. It's from chapter 18 when we cover suspense, error boundary, and concurrency. So this test by itself just covers the use case for suspense and error boundary for this particular component. Want to avoid testing implementation details. You want to lean more towards black box testing while you're testing your component. And this is the same idea from React testing library, which is using mock service worker to do the same thing that we're doing with Cypress Intercept. So on the left side, we have implementation detail test, testing that use state is being called, or React query is being called, or our post hook, our custom hook is being called when we click the save button. Instead, you want to test the consequences of clicking the save button. At the end, a network request should be going out to the backend. And it's better if you check this, because if you change your implementation, this test is still going to work. Doesn't really matter how you do the internals. Mock Service Worker and Cypress Intercept are very comparable. Here's my comparison, one-on-one. You can check the links. In my opinion, Cypress Intercept can make things a little more succinct, a little more flexible, but you do your own research and let me know what you think. You want to take advantage of the visual feedback of the component tests. So here in chapter 8, navbar, I'm writing the book and I thought this is a good test. But when I serve the component, I see that every single link is highlighted. Okay, I click on each, I go to the right link, fine, but there's a defect. This means visually, when you see the component, this quality of the feedback improves your TDD, inspires you to check for more tests, and lets you detect these defects before they may even happen. You get a feedback from the CLI tool, but you have to be very careful. For me, it was way easier to see the visual thing and think, okay, when I just click on something, only that guy should be highlighted, and the rest should be not highlighted. So I added a test for that. Best part is ad hoc is possible in a component test. So you can just run the component test, and then your component is there by itself without reading any of the rest of the application. You can go and click around, look at DevTools, look at your extensions. It's just next level experience for a developer when they're working on a component in isolation. It's just mind-blowing, this technology. Here's the final test for navbar, RTL versus Cypress component test. Again, different styles, same intent. Cypress may be shorter, sometimes less code because of all the other packages versus jQuery that it comes with. So it's easier to unselect or get the ones that are not selected. Versus the other API in React testing library is the same way of doing the same thing. If you cannot use visual tools and you want to do TDD, my advice is use Wallaby. I'd go for this tool when I'm testing the backend, especially. But if you cannot use visual tools, too hard to migrate, check out Wallaby.js. It will give you inline feedback as you're writing your tests, and that's the pinnacle of TDD, which you can have from a CLI or IDE tool. Right? If you can't have visuals, have that at least. You can use combined coverage to make sure your TDD was successful. So we go through that example in the appendix in the book. We get coverage from Cypress component tests. We get coverage from Cypress end-to-end tests. And we get coverage from Jest and React testing library tests. This means you don't really have to migrate from React testing library to Cypress component testing. You can already have tests with Jest, the old test maybe, or the non-component test, maybe you're testing your reducers or whatnot. You can just combine the coverage, and at the end, getting close to 100% coverage is not a challenge anymore. It's so easy. I've been doing this in multiple projects with JavaScript or TypeScript, doesn't matter. Combined coverage is the way to go. And it's not a be-all, end-all measurement, but if you have 100% code coverage, no one is going to say they're not confident in their application. What have we learned? The quality of the feedback with Cypress component testing improves TDD, component engineering, and early defect detection. Once you move up to routing, state management, and other complex things beyond components, TDD with endpoint tests is more relevant. With TDD, the key idea is to start with something failing. You want to do the minimum to get it to work, and then you want to try to make it better. There are the links and references, the book, the final application, and the inspiration that contributed to this content. Thank you very much for listening. You have a nice one. Bye.
Thank you so much for that super interesting talk from Murat. I know I'm very excited about Cypress component testing and seeing those applications. This was really fascinating. So Murat, can you please join me on the stage?
Hi.
Hi there, welcome. How are you today?
Great, thank you so much. How about yourself?
Doing well, thank you. So yeah, let's start off the Q&A by discussing the answers to your poll question. And so I was kind of interested in this, in that they seem relatively similar. Obviously, component testing took the lead with 43%, but unit and end-to-end right behind at 30 and 26%. So what do you think about those results?
I'd be curious to see if we did this poll before the talk and after the talk, if these would change.
Right. Yeah, I think as we went along, we started to really see some of the benefits that you highlighted. So very interesting to see how many people's minds have changed because of that. So we are going to have some questions here from the audience. So we'll go ahead and kick that off. First question is, what are the differences between the different JS frameworks for Cypress component testing?
But I think it branches a little bit, right? You have React, you have Vue, you have Angular, you have Next.js right now, a few others coming up. For instance, between Angular and React, right? The way you mount the component is pretty much the only difference, right? With React component testing, it's going to be very similar to how you mount your regular app. So if you have developed React before, you'll be very familiar with Cypress component testing in the React flavor. But if you've been an Angular developer, I think you'll like it even better, because Karma is notorious for having lots of boilerplate, and mounting would be, of course, different from React, but you're going to like it a lot better than mounting a component and configuring with boilerplate Karma. The same is similar with Vue, right? So it's just the way of mounting the component. The rest is exactly the same as an end-to-end test. So if you've used Cypress for end-to-end testing, then you're going to really be in your own game with Cypress component testing.
Yeah, so it's nice that you can just apply the same principles no matter what framework was really used to develop it. So do have a question here about code coverage as well. How do you achieve code coverage with Cypress component tests?
With Jest, it comes out of the box, right? But with Cypress, with end-to-end, it's quite easy. A few extensions and a few settings. With component tests, it's going to depend on your framework, and it's going to depend on your bundler. I'm pretty sure we're going to see some recipes, but if you refer to my book, it's a Create React application which uses Webpack, so there's like a good working recipe there. It's going to be a little different for Vite, or it's going to be different for Angular, but hopefully we'll get some recipes from the Cypress team, because I'm pretty sure people will be wanting some code coverage in this kind of low-level testing.
Yeah, code coverage is definitely always something that people ask about and want to consider. Do you know if you can also combine code coverage from different types of tests with Cypress component testing?
Absolutely. Cypress has been showcasing combined code coverage between end-to-end and regular unit tests from any framework. You can just add component testing to this mixture. You can triple combine it. So of course, when you have unit test in Jest, for instance, and then Cypress component test, couple that with end-to-end test, you can expect to see those numbers really shoot up, which also brings up a great use case for migration. So if you have already existing tests, let's say in React testing library, right, you can just keep them there. And then if you want to switch to Cypress component testing, you can make your new test with component test,
just combine the coverage and your overall coverage isn't going to go down. You may have to rely on services because doing this yourself in the CI can be not very future-proof. It's not very easy, but there are examples of doing it online if you prefer to do that. I think that's the way to go, the services.
Okay, great. And then we do have a question from Marie in the chat. To avoid test duplication between the backend and front end, would you recommend the Pack.js Cypress adapter as a way to leverage both contract testing and functional testing?
Good question. I have thought about this a lot, and I love the gap that Pack is filling because it mainly enables you to test integration before you deploy, right? So we haven't have this, it's in our books to get this working. But the way I imagine is maybe in the future, if we can get Pack there, right, it would be a nice complement to some end-to-end API testing with Cypress. And perhaps we can reduce those API end-to-end tests a little bit if we have confidence with some Pack tests, right? And that's going to enable testing freehand with Pack. And then after you deploy, some more spot checks with Cypress end-to-end, and that's going to be a nice test architecture. So of course, doing that transition, we can use the adapter, right? We can take advantage of that.
Yeah, I think you spoke to it when you talked about confidence, right? And understanding what confidence you already have in your existing tests across the stack, and then being able to build out from there with what you still need. So, and then another aspect of, the testing another question that has come up here is if you can perform visual snapshot tests with the component test the same way that you can with end-to-end testing.
Absolutely. It's just a one-liner, and I think it's going to be a little more stable with component tests because there are just less moving parts, right? We've applied this for our own component test library, which was very nice. For instance, hundreds of varieties of an icon, and then you just take a before and after, right? Lots of cost savings there.
Yeah, and we're coming up to the end of the time, but I did want to ask there too. Do you think that it's maybe more impactful to do visual snapshot testing with components testing versus end-to-end because of that stability?
Just less cost for higher confidence, right? That's what I shoot for with testing all the time.
Absolutely. Well, thank you so much for being here with us, Murat, to answer these questions. Attendees can continue to ask questions in Discord on the Q&A production track channel. But yeah, so thank you again for being here. We appreciate it.
So much for having me. Bye.
All right, now I'll turn it over to you, Balmer.
Thank you, Cecilia. That was a great talk from Murat. Pretty much liked it. And now I want you to meet Shai Reznik on his talk, Test Effective Development and to What End. Last year, Shai was here with us at TestJS Summit, and his talk was awesome. So I'm pretty sure this one will be too. But before we start his talk, Murat sent us a cool question. And he's wondering, what is an APM test? Is it a test for the main critical user journey, for the root feature? Is it when you threaten to quit your job after too many long work days, but you don't mean it? Or is it a single test for the critical functionality of the entire system? So go to Slido, type the code 0304, and leave your answer there. Also, don't forget to ask questions on Discord in the hashtag Q&A production track. And now let's give a big round of virtual applause to Shai. Sorry, and Shai, the stage is yours.
Hello and welcome to the Test Effective Development and to What End talk. This is me, Shai. I'm a real person behind the slides. It's not just a voice. Okay, let's go back to the slides and talk about what we're going to cover today. So today we're going to talk about cost-effective testing, and we're going to describe the problems with end-to-end testing and what is the most cost-effective end-to-end strategy for developers. So who am I? I'm Shai Resnick. I'm known as the test effective guy. Sometimes I'm known also as the Angular testing guy. I'm a Google developer expert, and I founded HighRes.io, which is an education and training company where we deep dive into how to write cost-effective tests, and we wrap the entire learning experience with nonsense humor to make it more fun and memorable. And over the years, over 170,000 people saw my lectures online, and I'm usually known for doing crazy lectures where we actually meet each other and are not infected by some weird virus. So I love to do crazy stuff on stage. Sometimes it's a game show or a rap video, and sometimes it's a stage play or a magic show. Okay, and you know, one of the testing lectures I did in 2018. So this is a great lecture if you want to check out a TDD lecture or test-driven development lecture, where I hooked up a device to my brain which could hear my thought process while I'm TDDing my code. So that's a fun one to watch. So my main goal in life is to help busy companies get more cost effective via testing transformation. So we take people who have no prior experience with testing and have tight deadlines, and we make sure they learn and they apply all the techniques slowly but surely until they completely transform their development process. We do it with respect to your current deadline. So you don't need to stop development. You just need to follow the steps. Why? Because my main passion in life is to prevent developers from sleeping like this and to get them to sleep like this, okay, normally. Because as I always say, test right, sleep tight, okay? And also by having this confidence, you can become more professional because you can actually apply it and change your code and make it better. So that's my passion in life, to enhance developers' life like this and companies' bottom line. So if you want to find out more and maybe know your biggest testing mistake, or want to learn about more testing strategies that you might apply that will enhance your life, check out this quiz. Okay, this is a test effective quiz which will give you a lot of benefits, and it's completely free. Now I have a disclaimer to make. As I told you, my talks usually are crazy and, you know, entertaining and stuff like that. But this time, this talk won't be a crazy talk. It will be a normal talk. The reason for that is as I got sick a few days ago, and I've been taking this medication. Wait. Sorry. So I've been taking this medication, and one of its side effects is that I lose focus and I forget the stuff that I want to say and stuff like that. So, yeah, like now, what I was about to say. Yeah, okay. So what I wanted to say is that because of that, I don't have the attention span to, you know, do crazy stuff in the middle and all that stuff. So this will be only an educational talk, but it will be awesome regardless. So please be patient with me if I forget like the next point or something like that. Just be patient. Okay, awesome. So now let's continue with the first point. Cost-effective testing. Let's talk about that. So back in 2009, I was full-time software developer, and I had a day job, and at night I worked on my own startup. So I was working like 20 hours a day non-stop, and I had tight deadlines, and I kept trying to meet them, and I rushed things and move fast and develop a lot of features. And I got to what I call the circle of doom, where because I was rushing and moving forward and didn't have any automation in place, so I produced poor code quality, which in turn produced unexpected bugs, which in turn, again, produced more poor code quality because I was afraid to touch the code to produce more unexpected bugs, which got me super frustrated, and I want to run around all the office and trash the entire office and set it on fire. Why? Because I felt like I'm drowning in some kind of a quicksand, because every time I tried to fix one bug I ended up creating more, and it kept being like this circle of doom and this vicious cycle that I kept feeling like I'm drowning and drowning and drowning until I got to the hospital, okay, because I couldn't breathe. I literally couldn't breathe, and they told me that I have panic attacks. And then in the hospital, I decided that I will stop working harder. I will work smarter, not harder. And I try to reassess what I'm doing. And when I came back to the office, I talked with a friend, one of the backend developers there, and he asked me, why aren't you testing your code? And I told him, first of all, I don't know how to test. I'm not a tester, and I don't have time to learn how to test. I know I have these deadlines. I need I need to work smarter. So he asked me one simple question. He asked me, when you're testing your code, are you like going to the browser and manually, filling out the forms or clicking the buttons or, testing the feature that you're currently working on? And I answered, yes. So he said, well, so you are already a tester, just an inefficient one. And that was a big aha moment for me, because I realized that, okay, I'm already doing this stuff, so let me check how to do it automatically. So I then went and studied a lot and read all the blog posts and books and lectures and all that stuff. And I saw all these terms like unit testing and integration testing and end-to-end. I didn't know like what's the percentage that I need to to write those type of tests and what is better and all the stuff. And I got confused. I got really confused. This is me confused. So I tried everything. Like I tried the unit testing approach, and I wrote tests, and then I learned that it's not enough. I need also to write integration tests. So I wrote integration tests, and then I saw that they are like flaky and they break a lot and all that stuff. And then I thought, okay, let's dump all of this and just write end-to-end tests. And then I realized that they are the most inefficient tests, although they give you the most confidence. But I was like, kept realizing that, it's like a very short blanket that you keep pulling one side and you're exposing the other side. I kept trying one strategy or technique, and it ended up hurting another area of the product. So then I stopped for a second and tried to reassess what it is that I actually want. So I said, okay, so as a developer, I wanted to do meaningful work. I want to create more features and to improve the product. And I also wanted to upgrade my skills and to become better as a developer, and also live a more balanced life and not work 20 hours a day and, missing my children's birthday parties or something like that. I wanted a more relaxed and stress-free life. And I realized that what prevented me from doing it is constantly chasing after unexpected bugs and fixing them, and also trying to fix inefficient tests, okay, that breaks a lot and stuff like that. So then I thought, okay, what can counter unexpected bugs is testing confidence, and what can counter inefficient tests is testing efficiency. I know, Captain Obvious, but bear with me. So then I got to the conclusion that we need a new approach, a better approach. Because if we think about it, we talked about confidence and efficiency, right? And when we talk about the strategies, tools, or techniques, we always have one strategy or tool that gives you more efficiency and less confidence. And sometimes it gives you more confidence and less efficiency. For example, like end-to-end test. And what I learned is that we can never get to 100% perfect, although I would love that. So the goal here is to find a balance, the highest balance that you can find between the confidence and efficiency. And then I thought about, okay, what can I call a metric that combines both the confidence and efficiency? And the only thing that came up to mind was cost effective. I thought about like, okay, what is the most cost effective strategy or cost effective testing tool? And then I thought about cost effective, maybe I'll call it test effective. And then is when I realized that I will take all of the stuff that I learned and I will teach it under the name test effective development, which means better terms, better strategies, and better tools for more cost effective tests. And what I realized along the way is in order to be more effective, you need to be more specific. So, you cannot just talk in umbrella terms or, confusing terms and one size fits all kind of approach. It's like a surgeon. When you go and do a surgery, you want somebody professional that has lots of tools and can use the right tool for the job, and not just a maniac with one tool, right? When you need to fix your leg or something like that. So that's exactly what the test effective development approach is, more specific. And some of the topics that I teach are like what's the right action scope to use, or the testing boundaries, or lasers and flashlight tests, and much more. But today we don't have time to talk about all of this. So we'll focus on just one strategy. And this strategy relates to end-to-end tests for developers, or dev end-to-end test. So just to be clear, we're talking about test the test from the client to the server to the database, all the system up and running, and we're testing end to end. Okay, so now a question for you: where do bugs hide? Okay, now where do bugs hide? Wait, where do bugs hide? Oh, what is? Sorry, I have a call. Sorry about that. Hey mom, I can't talk right now. I'm in the middle of a presentation.
Honey, do you remember that you moved out of our house 13 years ago?
Yes.
Well, you have these 2 boxes in our garage you keep saying you'll take, but you never do. We are not a storage unit, Shai. So please, for the 100th time, get those boxes out of here.
Mom, that's right. Boxes. That's what I wanted to talk about. Thanks, Mom. You're the greatest.
No, Shai, I'm serious. Take them.
That's right. Okay, so I have a theory of where do bugs hide, okay? And let me transition to the slide. This is my theory. Boxes, lines, and the big circle. I know, PhD level, huh? What is this theory? So the boxes are like the logic, the classes, the functions, the actual like separate parts of our app. The lines are the connectivity. So the connectivity between those boxes, between those pieces of logic, like calling some classes method from another class. This is like the connectivity between them. And you have the big circle, which is the assembly of the entire app. Like all the modules are imported together and combined in the right way, and the configuration is correct and all that stuff. So those are like the 3 parts of the app. And if we have bugs in our logic, for example, we want to protect ourselves from them by using unit tests. So we use unit tests to cover our bugs in the logic. And in order to protect ourselves from connectivity bugs, we use integration tests, right? But still, if we're using these 2, we still might end up in production with a bug, okay? Because unit or integration tests are not enough. We still have another place bugs can lurk in, and this is the assembly. And we need to protect ourselves. So what do we usually do as developers? We go again to the browser and, manually test it ourselves every time we, change something in the feature, right? So that's manually testing. But the issues with that is that it takes a lot of time and money, okay? Because, we are doing something that a computer can do, basically. But we're wasting our time, and our time costs a lot. And it's also very repetitive. So it's, again, wasteful in terms of like, it's not meaningful work. And also, there's no regression protection. So we don't come back to another feature when we test the feature that we're currently working on, right? We don't come back to another like section in our app and check if we didn't break that, right? So there's no like nothing that prevents us from introducing bugs into other areas in our app when we do the manual test. So then what we do, we say, okay, we have a QA, right? They will check it for us. But the problems with dev to QA cycle is that you have knowledge gaps. You need to now explain to another person, okay, what, like if the feature is done or not, if what exactly to pay attention to, what's not completed yet. You have knowledge gaps, right? That you need to communicate with another person to close those gaps, okay? And it takes time. And also it's a cost of 2 people that now need to spend their time on the same feature. And also it takes time, whenever you move the test to QA until you get a response back when they clear out time to test it, it can take a lot of time. And that creates more uncertainty because you're not sure when you will get the response back that they found the bug and now we need to stop what you're doing and go fix that bug and stuff like that. So, and also there's research that shows that the longer it takes to detect a bug, the more expensive it is to fix it. And that makes sense because, fixing a bug in production is much more costly and wastes so many people's time by the time the bug gets there than fixing it while coding, right? Okay, so what's the solution? The solution are automated developer end-to-end tests. So instead of manually testing the code or counting on QA to do that for us, we need to write the end-to-end test ourselves. So the benefits of them is that they shorten the feedback loop, they simulate the real system, okay? So we don't have connectivity bugs or configuration bugs, and it's a one-person job. So again, no knowledge gaps, and because you are the developer, you know what to test, and also it's just one person cost and not two. But they have downsides. So end-to-end tests, automated end-to-end tests, they take the longest to write, because they require the longest setup to write. And also they take the longest to run because, again, you need to boot up all the system and all the stuff, and it takes time to do that, especially when you run a browser to do that and all that stuff. They are the most fragile because they break more often on every little change in the system. Every little change that you do can break the entire test suite. And they are the hardest to debug because when they fail, you don't see exactly where is the problem, and that takes time to find that out. So those are their downsides. The solution is... What is the solution? Sorry, I forgot what... Oh. She doesn't understand. Okay, let me just real quick answer it and... What, Mom? I told you I'm in the middle of a lecture and I just lost again my train of thought.
I know. I just wanted to tell you that the Friday family dinner we planned to have just got cancelled.
Why?
Your genius dad wanted to try out a new oven, and now he's on fire.
What? What do you mean on fire?
He's literally running around the house trying to find a water source of some kind.
So why don't you help him?
Because I told him not to do it, and now the family dinner is off.
Mom, you need to go and help him.
He'll manage. I'm mad. The entire place smells like smoke.
Smoke! That's it! Thanks again, Mom. You're a genius.
Oh. Okay.
That's right. So the test effective solution for it are smoke tests. Huh? Have you ever heard about smoke tests? No? That's why we're here. Okay, let's talk about them. Okay, so the origin of smoke tests, the name comes from hardware, depending on who you ask. It either comes from hardware testing, where they plugged it to the wall, and if it didn't blow up smoke, the test passed, okay, if it didn't blow up. Or from plumbing, plumbers used to blow smokes through the pipes to see if there are no any leakage, and the smoke goes to the end of the pipe, okay? So that's where the name comes from. Yeah, so like this. So the official definition is smoke tests are preliminary tests to reveal simple failures severe enough to reject a software release. This is by Wikipedia. But my definition, or the more high-resy definition, is few, happy, and critical. Meaning few tests, only the happy path or the successful path, and not like error handling and stuff like that. And the most critical path or user journeys. And let's talk about what is critical. So for that, let's talk about the bug taxonomy. We have three types of bugs. We have what I call the 9 to 5 bugs, the 8 p.m. bugs, and the 3 a.m. bugs, okay? And these are the worst. So what smoke tests cover are only the critical, which are the 8 p.m. and 3 a.m. bugs. And if you write tests for those, you will get the most ROI, or the most cost effectiveness. So let's talk about each of them. The 3 a.m. test that we need to write in order to cover the 3 a.m. bugs is what I call the main critical user journey. Okay, this is what we need to focus. So for example, if we take a website like eBay, what is the main critical user journey here? So probably it will be like the user searches for a product, then they click a product, then they add it to the cart, they create an account, and they purchase, and they get to the thank you page. So that's a simplistic view of what the main critical path on eBay is. So this is what you need to cover when you write the 3 a.m. test. And that's it. Now let's talk about the 8 p.m. test, or what I call root features user journeys. Okay, so what is a root feature? So basically, root feature is anything on the top level menu that you have in your app. Okay, so for example, in eBay, you have like, when you log in, you have the activity or the messages or the account, if you go to like the settings or something like that. So each one of the menu items is a root feature, right? This is how people navigate usually to our root features. So in every root feature, you need to ask yourself, okay, for each root feature, what are the sub features that if they won't work will cause a loss of a customer or just loss of money for the business. So this is what the question that you need to consult your product team or the business team or the marketing, sales, CEO, whatever, whoever is in charge in your company. You need to ask and to investigate what is the most critical path for the users. And for example, here it could be like the bid/offers out of all these like safe searches and safe sellers and all that stuff. The most critical one might be, I'm guessing here, the bid/offers. Okay, because if this doesn't work, you might lose money or something like that. If you go to the account, for example, which looks different when you click on it, when you look at all these sub features here, you might want to test the payment information sub features and go to each one of them and test the main flow there and see that it works, because this might cost your business money if they won't work. Or you might want to test also this, the personal information or addresses. If, they want to change addresses in order to order something, this, it changes between business to business, but the methodology is the same. So these are the 8 p.m. tests. And the key thing to know about this type of test is that you need to write few of those, but each one of them is longer than what you usually write. So this is what I call multi-action tests. So the reason for that you want to, keep few but longer tests is because you have a cost for each test ramp up, right? The cost of like running up all the machines and setting out the data and stuff like that, it costs time and also setup code and all that stuff. So you want to make sure that if you're already there, you just move to the next sub feature and test that flow and write like a test per root feature. And that way you get the most cost-effective test and not lots of tiny tests that will take longer to run and also to track down and stuff like that. So you probably ask yourself, what are the tools, right? What are the tools? And okay, I forgot. Sorry. Let me call my mom and see, maybe it will remind me. Wow. Let me call her real quick. Okay. Hi, Mom.
Shai, I can't talk right now. We're on the way to the hospital. Your brilliant dad thought it was a good idea to pour water on the burning oil.
Is he okay?
He's fine. No serious burns or anything. He just lost his eyebrows and now looks like your Aunt Sarah. We might need to paint him new ones or something. So don't say a word about it next time we meet, okay? Got to go.
What?
Bye.
Well, this didn't help at all. She wasn't helpful. So I hope my dad is okay. Anyway, you know what? Let me just look at the next slide and I'll see if if it rings the bell. No, I didn't think about it earlier. Okay, let's see. Oh, right. Smoke testing tools. Okay, what are the smoke testing tools? All right. Okay, let me hide. So we have lots of great tools here in this list. So these days, the ones that I recommend the most for developers are Cypress.io and Testim.io, which recently opened up a new free plan for developers, which is great because, Cypress.io is the most popular one and has great development experience and debugging experience and great support. And Testim actually takes it to the next level. It's even faster. So it took me the same test that took me in Cypress to write in 20 minutes. It took me to write in Testim for like 20 seconds. Okay, because it just record what you're doing and it's smart enough to know. It is like an AI that knows if something changed but didn't change drastically. It knows not to break the test. So it's very like futuristic, next level thing. But anyway, all of these tools are great, but these are the ones I recommend. So now we see that the smoke test benefits are that they are much faster than a full end-to-end suite because you write just a few of those, and because of that they are less fragile. So, you have less reasons to go and change them or fix them. And they are easier to debug. They're still end-to-end tests, or they are like harder to debug than unit tests, but they're easier to debug because you have only a few of those and not, 500 tests where 50 fail and you need to now track down the root cause of 50 failing tests. So that makes smoke tests easier to debug. And also they prevent critical bugs, which this is the most important thing. So you get a lot of value for not a lot of effort. And this is the critical thing to remember about smoke tests. And that's why smoke tests reduce critical bugs in the most test-effective way. So let's summarize what we learned today. We learned about cost-effective testing, we saw the end-to-end testing issues, and we talked about smoke testing, which is the most test-effective end-to-end strategy for developers. So if you want to learn more about test-effective strategy and see what mistakes you might be doing in your current testing, check out my free quiz, fill up a few questions, and you'll get your assessment on what will be the most test-effective approach you can take. Cool, thank you very much. I'm Shai, this is my posse, and here are the links. And that's it, that's Sarah. So, hope you enjoyed. You can reach out to me if you need anything, if you need to ask anything. And my mom says hi, by the way. So she wrote me a text. So enjoy the rest of the event.
Oh gosh, thank you, Shai. That was an amazing talk and a pretty funny one. So would you like to come and join us on the stage? It seems that Shai's dog is gonna answer the full questions. Is it correct, production? Where's Shai? Oh, there he is. Hey, Shai, how are you doing?
Hello. Yeah, my dog cannot talk. He's after like this, the surgery and stuff. So my parents.
I'm glad you came then. Yeah.
Yeah.
So we have the answer of your pool question. Can you see the results? What do you think about it?
Let's see. Wow. Okay. First of all, the majority were right.
Yeah.
But I really like the the second option, which now it's
28% of
don't
people,
cheat.
yeah.
Don't cheat now. You chose the second one. That was the the correct one. Yeah, but I like it. Means that people pay attention, so that's great. I hope this like the terms will stick and people will start calling 8 p.m. and 3 a.m.
I really like the idea of thinking about the time you are working or the time you're not working, or maybe the time you're sleeping, right? Like that you don't need to be awakened to fix something that is going wrong at that time. We
Based
have a
on
few
a
questions.
true story. Yeah.
Yeah, so true. We have a few questions from the audience here. So the first one is from Lia Moreira. Won't it be a little biased devs writing end-to-end tests?
Yeah, that's a great question. Let's see if I can pin. Yeah. Okay. So I won't get distracted by seeing myself twice. Okay. So that's a great question. Now the idea here is, so I have an in-depth course where I talk more deeply about the way you start even thinking about, okay, where should I start from, even approaching it. So the first line of defense, let's say it's the product. They should define the product or the business side that talks with the users and know what are going over the analytics or the user journeys, and based on what the user are most likely to do, that's the best way to write your smoke test and to base them on that. Now, if that doesn't work, I have the 3 P's. The first is the product. And the second one is let's say I call it PIF, the past interruption factor. meaning, you know, how many times people did like, hey, stop what you're doing. Can you fix that
Yeah.
bug? You know, so if there's like an area that keeps repeating, you want to cover that with the smoke test, right? And the last P, I didn't have like I didn't find like a word, so I call it common sense. So just apply common sense. Okay, so that will be 3 P's. But yeah, so the idea here is that these tests are intentionally not thorough, like, you know, a SDET or a QA automation engineer would write and maintain, because, you know, our job as developers is to develop and to have the best, you know, combination of confidence and efficiency, like what's the most test effective way. And so we could focus
it's
on
still your
delivering
job
value.
to develop good quality code, right?
Right. And so that's the main purpose. So that's why, you know, if you can get the requirement from, you know, an authority on the user side, that will be the best case scenario. And then you just like write a test by that. But most, you know, companies usually, not most, but you know, a lot of companies are that I meet as clients and stuff, they often tell me like, we don't get even the requirements, you know, in an orderly fashion. We don't know what to write here. So we just, you know, we don't do it because we don't know. And now what I say is, don't wait to be a perfectionist about it. Just start from something, so we'll at least get this confidence instead of waiting for the feedback loop, you know, with the QA.
Yeah. And I honestly, I personally believe that I actually worked with developers that are really good at writing tests. Sometimes what I think it happens is that they don't have the permission to write them because there is a QA team, a testing team. But when you actually give permission to developers to write tests, they get very creative and they can do things that QAs maybe wouldn't think of. So I think it's like, of course, there may be some bias, but it doesn't necessarily need to be the same developer that is writing the code that is writing the tests as well. Of course, it should be the case if you are doing TDD, but like I think both work pretty well.
I think, again, if you don't have the requirement, so it's unavoidable to have the, you know, the bias test, but at least you have something to start from, and then, you know, fix it or change it according to, you know, the business requirements and stuff.
Yeah. There's another question here, which I am very curious to hear your thoughts about it. So you mentioned in your talk that end-to-end tests are usually fragile, right? And what can we do to write less fragile end-to-end tests? Would, for example, using tools such as Cypress help us with that?
So I feel that it's not the tool, it's the amount and, you know, the coverage of those tests that makes them more fragile. Because, you know, when we're talking about end-to-end tests, we need to remember that we're testing multiple layers of code with lots of logic and conditions inside of them, of these layers. And the more thorough we want to be with our end-to-end test, the more chance that we'll have breakage, or like they will break a lot whenever we'll change something, you know. So that's why it's not the tool. You can write it, you know, in a command line tool. You can write it in Cypress. You can, you know, in any other tool.
So maybe like rephrasing the first question is, what can we do to write less fragile tests?
So the idea here that I'm trying to promote with smoke testing is to write less tests, which are more meaningful, that cover the critical path, and that way you minimize the amount of fragility. I don't know, like
I see. And then you have other layers of tests that would cover other scenarios as well.
Exactly. It's a combination. It's not just these tests.
There's another very curious question here, which is, what's your thoughts on eliminating end-to-end tests in favor of a mix of integration and contract tests?
So I feel that contract tests are amazing, and integration. So integration test is an overloaded term. It depends if you're meaning because contract test could be instead of integration test. So maybe they mean like integration tests from the end to fake server, and then contract test, and then from the microservice or the service to the database. That could be covering stuff, but there I feel must be a sample size or like a few really strong like smoke tests which are end to end, because if you won't have that, you might fail you might write your contract, maybe you might not cover something with the contract test or something like that, you will miss. And you want to have the smoke that coming from one pipe to the other, you want to at least see it, right? So that's why at least a few end-to-end tests to see that the system is up, and not like
and if you have just a few, you don't have that much to worry about, because
exactly
if they break,
and
at
you
least
should
it's
write
just
your
a small
contract
setup.
and you should write your contract test regardless as an additional layer, and not instead of.
Makes sense. They complement each other for sure. That was an amazing talk. Thanks for being here with us, Shai. It was a pleasure.
Thank you very much for having me. If you want to know more, highres.io.
Thank you. Bye.
Bye-bye.
And so, Anuradha, back to you now.
Can't hear you, Anuradha. We can't hear you.
I think we are having some technical problems here. Can we have the slides moving? So I'm gonna take it away, and with the power-packed talk. Now we are towards the end of the TestJS Summit for today. Tomorrow there's more. At the end, at the start of the event, we told you about the raffle, and it was so nice to see all those engagements on Twitter. So thank you all for all the tweets. And now the time for the raffle. So let's take a look at some of the tweets. Cecilia, would you like to mention about the tweets, please?
Absolutely. Thank you so much, Valmer. So thank you to everyone who participated today and used hashtag TestJS Summit to tweet. So thanks to Maria, for example, for learning and inspiring. Love to see your setup there. We also have a tweet. This one, I'm in this one. Looks like you're drinking your soda, so that's good. Staying hydrated throughout the talks today. We also had a tweet up next from Vitor Neves, watching TestJS Summit. Looks like about to tune in to Marie's talk. So thanks for tweeting and letting us know how you're enjoying the conference today. And we also have a tweet here from Lorraine at Lorraine Garudi with her setup, also watching Marie's talk. Thanks so much for tweeting to us. And last but not least, we also have a tweet from Wayne Jones, learning a few things about testing JavaScript applications at TestJS Summit. Awesome. And so taking a look at those tweets, I think I can turn it back over to Anuradha. You here with us, Anuradha?
Yes, can you hear me?
Yes, we can. Thank you so much.
So,
all right. So we'll go ahead and I'll go back to you and let you switch over. Perfect.
Yes. So we are going to do a raffle. So let's see. Can we spin? Can we spin the raffle? Let's the raffle begin. Yay. Whoa.
Hey.
We have one winner. And we have a spin again.
Who is it gonna be?
Yeah, Cecilia, I think you are the lucky one, like lucky charm. So yeah. Awesome. Congratulations. So
congrats for the winners.
yes,
congratulations. Thank you so much.
Congratulations for the winning, and I think the team will reach out to you for your the whatever you won today, the T-shirt and the multi-pass. And with that, wow, what a day today. So it was full of, I hope it was full of so many learnings for you all. And we would like to thank all our speakers for sharing your experiences and knowledge with us. And also thank you to you, the lovely audience, for being with us, for watching, for participating in our discussions and speaker Q&As. You are the best.
Yes, thank you. And also, once again, thank you to our sponsors for all your great support of TestJS Summit, Sauce Labs, Stackhawk, Stream, and Yoast. We could not be here without you, so thank you so much for your support. And also, thank you to the Git Nation team for organizing this event. There is a lot of work that goes in behind the scenes to make this all possible, and it's really been such an impressive event with everyone contributing. So thank you to the Git Nation team. Palmer?
Sure, and if you want to attend more conferences from the Git Nation team, you can get a Git Nation multipass, so you can find more about it on Git Nation portal. It's portal.gitnation.org. And also you can subscribe to get more talks from previous events. So all today's recordings will be uploaded to portal.gitnation.org, so you can check them out there. The full ticket holders will get instant access to all the talks, and the free attendees will have access to them in around a month. So stay tuned, and I hope you enjoy all the talks. Anuradha, back to you.
And again, your feedback is very important to us, so it helps us to keep making the event even better. So we have a form available to you at testjssummit.com/feedback. Go ahead, give us the feedback, and we'll take care of it. And there will be more discussion rooms tomorrow, so do not miss them out and join the special chat. And you will also get the schedule for them and the list via email.
All right, so if you think that we are done, you are wrong. We can't leave you without a remote after party. So we do have a great after party program. You know, after parties, some may say the best part of any conference. So everyone is welcome to participate. We're going to be playing Draw Battle and have lots of fun getting to know each other, chatting about today's amazing talks, hanging out with some of our speakers. You can find the link on the watch page in order to join us in spatial chat for the after party.
Thank you
I
again.
think we are done, right?
Yeah.
Yes, thank you so much, everyone. Yeah, we'll see you in the after party, and thanks again to all the speakers and everyone for being here today.
Bye.
Thank you. Bye.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to...
bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
Walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
Nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
see's my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
nightmares creep while you and me repeat. This bittersweet heat is suffocating.
Introducing StackHawk. StackHawk makes it easy to find and fix security vulnerabilities before deploying to production. With lightning-fast security scans, returning results for review and triage in minutes. Get started for free today at stackhawk.com.
walking alone, the streets are empty. The only thing I can see is my own silhouette. I'm getting stronger, step by step. The clock is ticking, but there's no time for regrets. I've been flying from town to town, from London to
nightmares creep while you and me repeat. This bittersweet heat is suffocating.